eye, right?
That's
Think
correct.
medium in between vapors, particles, all that stuff, right? That causes things to be obstructed. When we talk about the atmos, dude, like you're contending with the atmos between you and 10 miles or 2 miles or 1 mile, right? So things start to disappear bottom up because of refraction. That's the whole
Yeah,
thing, dude. That's
we're
when you
talking
talk.
about perspective, not refraction.
Yeah, I know,
Yeah.
but
Look, can
perspective
I
alone
just want
is
to add
hold on.
something.
Perspective alone isn't sufficient, right, to make things disappear bottom up. I'm granting you that. I agree with that, right? In a vacuum, you would expect things to just blink out, right? They get so small that you can't actually resolve the angular resolution, right? Your eye isn't capable of that. Optics only have a certain limit to be able to resolve that angular resolution, right? It will just continue to move forward and forward and forward. But because of the atmosphere, right, things start to disappear bottom up because refraction is actually the reason why things become obstructed bottom up because the light rays near the bottom of the object are arrested by the atmosphere itself. They refract towards the denser medium, right, which is towards the earth and crashes into the surface of the earth. And they can't actually reach the observer's eyeball. That's it. We've demonstrated this in the lab.
Yeah, I think you just, well, it's the opposite of what you said. They
I'd
bend
like
towards the
to.
denser medium, but that
Hey,
doesn't cause
Pinky,
sinking refraction.
I just want to
Light
add
bending
something
up
to what
causes
Lion
sinking
was
refraction.
saying. Yes, that's correct. Light bending, not down. I just want to make one point really quickly, and then I'll go on mute. Okay, so in the live stream text, I just posted this sky-free observation. What they do in here is they introduce cooler air up higher. So you were saying before, obviously it gets cooler as you go up higher. Now, in this is a smaller scale demonstration, so we have apparent downward obstruction of things. So all of a sudden we have a flat floor, and then it looks like things are sinking behind the horizon, formed on the flat floor. Okay, and that's because the light is deviating towards the cooler air because it's more dense. Now you're saying how come a mountain can look a little bit lower off in the distance? Because you have the exact same situation that's happening in this observation. You have cooler air up higher, warmer air down lower, and you have something looking like it's sinking a little bit in the distance. It's the same thing, and you just said that happens. So,
Well,
I
that's
don't
a
know what the
specific
confusion
claim. You're
is.
saying Gaspard observation happens because of sinking refraction. So if that's a
Sorry,
specific
what
claim
happens
you're
because of
making,
sinking?
then you'd have
No,
to
no,
back
this is
that
what I
up.
said. Yeah, I can back it up. I can give the
And you did say it was
citations.
perspective, by the way. You did say that.
No. Perspective. Look, perspective is just something that happens. I never said it appears lower because of perspective. I said it
Yeah, but
appears
neither did I.
reduced and more towards your eye level because of perspective. It's not going to look like it's way up in the sky because it's higher because we have perspective, and it's reduced so much in angular size. It's going to go towards your convergence point, like Lion said.
Yeah,
All
but
I'm
that
saying.
wasn't my point. The point I made that you responded to, what I didn't say that. I didn't say that it should appear way up in the sky. I just said if it's taller than you, you should never have to look down at it ever with perspective.
Yeah, with perspective alone, right? That's just one of many factors.
Right.
I know, but I
Yeah, you
said
have to
why
contend with.
okay,
Okay, so you
fine.
have to
I said
consider.
why are you
Hold on,
looking
dude.
down
You have
at
to
it?
consider.
And he said
You have to.
perspective.
You hold on, dude. You have to consider perspective. You have to consider refraction, Rayleigh's criteria, and the light attenuation. All these things is why we see things obstructed from the bottom up, and why they seem to dip below the horizon, the axis of the center of the axis of the eye.
I know, and you said that for Gaspard, because the air's denser, closer to Earth, light's going to bend downwards, and that's going to make it disappear bottom first, right?
Well, yeah. So if you look at Andrew
Yeah.
Thomas Young's paper, right, you have 4 different types of refraction. Besides, I mean, exclude cosmic refraction, all that. So we have above the horizon, you have towering and looming refraction, superior
We went through
mirages.
this earlier already.
Okay, okay, I understand. And then below the horizon, you have what? You have stooping refraction and sinking refraction, right? Stooping is where it looks like it's compressed, right? Things seem to start getting compressed as they go towards the convergence point.
Yep, like
All
the sun.
these different types of refraction can be caused by light bending towards the same exact direction. Now, I know in the globe, you guys say, oh, no, it's depending on whether it bends up or bends down, you're going to have different effects. What Andrew
Well, that's
Thomas
what
Young
DJ
actually
said.
showed, yeah, I know this is the common consensus. But what Andrew Thomas Young showed is that actually, depending on the rate of refraction, right, where light can be bending the same exact direction and can cause all 4 different types of observations:
So my
towering,
I
question
don't.
looming,
I don't think so.
sinking, and
is,
stooping.
look at this. Look at this picture. This was a thing that was going on, I think, in the earlier days of the flat Earth stuff with Jenna Fredo and the CN Tower from across Lake Ontario and Alcott, New York. And the CN Tower, right? It's a huge object, right? Like 1/3 of it is completely missing, as well as the Toronto skyline. The majority of the Toronto skyline is missing. And that particular region, you can go out on days where the air is a lot hotter than the water. You can go out on days where it's a lot colder than the water. And yet there's never a time that you could go out there where the refraction works in any way that you could ever see, really more than 2/3 of the CN Tower or the Toronto skyline. There's never a day you can go out there and then see, and see the normal Toronto skyline. So what is happening there? Even though you can go
So
out on a day when it's 100 degrees out and the water is 55 degrees, or you can go out in the wintertime when it's like negative 20 degrees in the air and the water is a few degrees above freezing. There's never a situation where you could
right,
ever
well,
see
yeah,
that skyline.
refraction is not your friend, dude.
Kryptonite for the globe. Really.
Refraction is not your friend. You understand why? You understand why? I know you guys
No,
love
I
using
don't understand.
refraction.
I mean, you're saying
So
that no matter what the temperature gradient looks like, there's always going to be like 1/3 of the CN Tower missing from 40 miles
dog,
away, right? Like, I don't understand.
do you understand that refraction is why we can't see as far as we normally can see? So visibility increases when refraction goes down. You guys are saying visibility increases when refraction goes up. You have to say that, because when we can see way more, right, than what's geometrically possible, you guys say, oh, it's because of refraction. But actually, no. Visibility increases when refraction goes down.
Yeah, true. And infrared debunks them. Infrared observations, they debunk their claim that refraction will make you see farther. No, because infrared, it reduces the refraction effect. So less refraction with the infrared filters, we see farther. It's against your claim, meaning that you're wrong.
Yep. So he gets it.
So is there a day where you can go out with an infrared, camera and be able to see the entirety of the Toronto skyline from Alcott, New York?
Well, you're limited, dude, because it's not like we're looking through a vacuum. Even on with ideal conditions, right? With
Wait a minute. We're seeing the top of the tower and the buildings, which are further away than the bottom.
No,
yeah, I know this, bro. I'm trying to explain to you the reason why you can see the top and not the bottom is because the bottom, right, is closer to the surface of the earth. The closer that you are to the surface of the earth, it's no difference than when you're out in the ocean. You got the marine layer to contend with, right? You have dust particles, you got evaporation, you got heat rising from the surface of the earth. That's going to cause light to be arrested, right? Arrested in what? Diffused or hit the surface of the earth, never making it to the observer's eye. So that's
But
why,
that's not what we're seeing. We're not seeing
when you
like
have
the top
a
of the building and a
skyscraper,
haziness.
when you have a
We're
skyscraper, you would expect, right, that the bottom of the skyscraper would be obstructed first.
Okay, so if what you're saying is true, then what we should expect to see is that the top of the building would be clear, and then there would be like a hazy area, like when a building is rising up out of the fog, and then you would see the water below. But what we see is a hard water line that cuts off everything above that, right? That we can clearly see the objects above the water line. We don't see some hazy region of dust and whatever bullshit marine layer that you want to bring in.
That's
That
not
would cause a
bullshit, bro.
haziness.
That's a big
That wouldn't cause a hard delineation, right? It would just be fuzziness.
That's just you saying nuh-uh. When you know for a fact that at the surface of the earth it's the most chaotic, right? That's where all the evaporation's happening. That's where all the heat's rising from the surface. That's where all the dust is at and all the pollen and all the fucking particles, right? So obviously, light that's reflecting off that fucking building, the closer it is to the surface of the earth, the earlier it's going to get obstructed. Dumbass.
So from Carlsbad, California, when the sun is setting directly behind Catalina Island, which is almost 2,000 feet high at the highest point, and we still see the sun directly set into the water, we never see the silhouette of Catalina Island from Carlsbad. What's causing that? How is it that we're seeing the sun get cut off by the water as it goes away, and we never see the silhouette of the island that's in between? That's like 2,000 feet high. What's causing that island to just disappear?
We've been
Yo,
over this
somebody else can
before.
take this. I'm not trying to lose my
Yeah,
temper.
I've looked it up. We've had this same conversation, and we looked up the average visibility for that location, and it's way below the distance that you're talking about.
But we
And
can
you
see
can
the sun. So if something is blocking, if something is
yeah.
between the sun, why wouldn't you see the silhouette of it? Because if we can see the sun, obviously we can see far enough to see the sun, right?
All right. So because the sun is up in the sky, it's extremely bright, and the light coming to you from the sun is much more powerful than the dim light that's just reflecting off the things that you're talking about and trying to push all the way through all of that atmosphere to make it back to your eyes. It's not possible. But the bright light from the sun, right? It's like the Canigou one. Okay, when you look out, you can't see Canigou on that particular day at all. And it's not until the sun goes behind it and that bright light from the sun is powerful and push through all of that air and make it back to your eye. So then all of a sudden,
So we're seeing the
you're like, oh,
silhouette
there's shit.
there.
There's a mountain there that the light wasn't making it back to my eye from, but now we have a brighter light source. We can see the sun.
So why? So we should be able to see the island then, right? Just like Canigou.
Like
Well,
Canigou,
is
like
the sun?
refraction
If
is
the sun,
inspired.
is the sun setting right where the island is? Do you have footage of it? I don't think you have any footage.
Certain times of year, the azimuth of the sun directly in line with where the island is supposed to
Okay,
be.
we'll grab that footage, and that'd be cool to go over that.
It's just
You
one
know,
of those
when you have
things, man.
It's just
one of those.
for
where you don't
Canigou,
have
it's
footage
just
to back your claim.
it's just a coincidence. Refraction is just conspiring with the time of the year, so you can see Mount Canigou. Every time refraction is the same, so meaning that the temperature is the same, everything is the same, so you can see Mount Canigou like that every time, every year.
Refraction's conspiring.
Yeah,
Conspiring with the flat
conspiring.
earthers to hide the globe from the globers.
Yeah, it makes a rendezvous with the mountain and the sun. Oh, look, I will be there during that time of the year, so just try to not be late. So it conspires with them, so you can see that effect, that phenomenon happening every time, the same time. Yeah, it's just a method of coping. Typical globers. What do you expect? You just explain to them that when you reduce refraction, expecting to see what you globers are claiming, that with the refraction you see less. When we reduce that refraction effect, we see farther. Why do you want to jump to some mountain? Why I don't see the mountain when the sun? Oh, okay, so it already opposite of what you just claim about refraction. We don't care about the mountain. Refraction won't do that because we see it. We tested it. More refraction, you see less.
This is pretty
Less
common
refraction,
sense,
you see
bro. Like,
farther.
yeah, the more refraction, the less visibility, dude.
Yeah,
This
yeah.
is predominantly the case. You know, light tends to bend towards what? The denser medium, predominantly, right? Now, granted, there's some anomalies. There's internal. There can be like a super mirage due to internal a boundary layer, inverted boundary layers, and internal reflections and all that. But predominantly, light bends towards the denser medium. Where is the denser medium at?
And why are people
Wait, hold on. Where's the
comparing-
denser medium at? Usually, normally,
Normally, it's always
towards the surface of the earth,
Towards
right at
the
sea
earth.
level. That's where the denser medium is at.
This is
It's
but Lion. This is where the globers actually screw it up because they're sure the PSI is higher, lower, but if light bends towards the denser medium, that means it's downward bending light, which makes things loom up. It makes things look like they're higher, and that's what their claim is to explain
their
these
claim is, yeah.
observations. But what's actually happening and what mainstream optics says is that it's about the optical density. The optical density is controlled by the temperature of the air. So if you have warmer air down lower, and then you have a layer of cooler air above it, the light's going to bend upward, and it's going to cause things to look like they're sinking, look like they're going down, because optical density is king when it comes to the refractive index, not this vast gradual change of this atmospheric density that reduces with height. Because the amount that just say it's 14.7 psi at sea level. Let's say we're standing at the ocean. It's 14.7 psi at sea level, and we've got a P900. We're looking at an oil platform that's 9.4 miles away. The density over that 3 or 4 meters from the ground up, it barely changes. So that natural change in the density gradient, it's F all of an effect. What completely dominates is the temperature gradient. So if you've got much cooler water, it's going to make a layer of cooler air down lower, and then it's going to get gradually warmer as you go up. Then you're going to get some looming, right? But if you've got the warmer water, then you're going to get the opposite of looming. You're going to get sinking, and the globers conflate the natural progression or decrease of the refractive index to the psi of the air, but it's dominated by temperature, according to all the experts.
Yeah, that's what I was talking about. Yeah, inverted boundary layers, where those are anomalous situations, though. Predominantly though, what we have is the denser air at the bottom and the lighter air at the top. That's universally the case. But you'll have like specific locations like near the Straits of Gibraltar, where you can have more calming, superior miraging, where you won't see that anywhere else in the world except at the Straits of Gibraltar, because for whatever reason over there they have the conditions needed to actually have that effect. But that's not normal. Normally you just have refraction making visibility impossible to beyond a certain point. Light does tend to bend towards a denser medium. If you have this inverted boundary layer, light can bend up in those specific scenarios or locations. But the point is that when you have light bending down towards a denser medium, that's towards the crust, that's towards the earth. So when light bends down towards the earth and hits the earth, it can no longer reach the observer, and the light closest to the surface of the earth is going to naturally bend down towards the denser medium, becoming arrested and completely diffused when it hits the earth. No, that's why things disappear bottom up, because the bottom of the objects are obviously closer to the surface of the earth, causing them to be obstructed first. Plus perspective, right? It's called the viewing angle. Things become obstructed bottom up. That's just so a combination of refraction, perspective, light attenuation, Riley's criterion, Fermat's principle. When you factor all these things in, that's how you end up with bottom up obstruction. That's how you end up with the sun disappearing. When due to perspective alone, right, the sun shouldn't just disappear the way it does. But we're not dealing with just perspective alone, guys. Go ahead.
Jeremy, you still here?
Oh, I'm here. I'm always here. What's up?
Oh yeah, you were saying something before about how it would be good to have some kind of like some side views of these laser tests.
Yeah, I mean, there's issues with that though, because um every camera is different, right? And it has a distance per pixel that'll be inside the thing. Like, say you were to go take a picture of the Empire State Building, right? With your camera, we could measure, how high the Empire State Building actually is. Then we could get your photo, see how many pixels are in it, and then we can see how many feet or inches are in each pixel. You know what I'm saying? So when you're trying to go see if the light's bending with the laser beam on the side, you have to have a camera that has really good, like a high amount of pixels, because you want to have that number be as low as possible. Like, you want the least amount of distance in each pixel, so that way you can differentiate, because you could have something bending and not even see it in the thing because there's not enough definition. You know what I'm saying?
Yeah, absolutely, man. I've got a really good side view of a laser test that I don't know if you guys know Lanolin, but he did the Abomination of Desolation documentary where he did a bunch of laser tests over Frozen Lake in Alaska, and he set up a bunch of weather stations. But he actually invested in one of the best rectilinear lenses. It's a wide angle rectilinear lens. I think it's 9 millimeter focal length, but it has next to no distortion. It's extremely expensive lens. And what he did was he did a 6 mile laser test, and he took a long exposure. So he leveled everything correctly. He took an 8K image. It's actually a bit over 8K quality, and he got a side view using the rectilinear lens.
Yo,
And
that's
he
another
actually
thing.
yeah. So this is he's trying his best to mitigate lens distortion. So he has the entire 6 mile transit from left to right of the laser.
That's
And
awesome. That's awesome. But
yeah,
that's another thing though. You want to make sure your camera, you want to try to make sure the center of your camera is at the center of the laser. You know what I'm saying? And as you're backing up from that, do you do it off of
well,
do
this
you
is
do
the
it
good
off
thing.
go ahead.
This is the good thing because what he did, he actually, because flat earthers, right? We can always give the globers some grace. Our observations are so far off matching the globe, we can give them a little grace. So what he did was he actually had the horizon was quite a bit above the center frame. Okay, giving the globus some grace there with the lens distortion. And so what you can do with this 8K image, because it's 8K, and you can vertically squish it. And when you do that, you can see that the laser is actually slightly, ever so slightly bending upward over the distance when you compress it. So even though the laser is above center of frame, which would cause it to be convex, and it's an 8K image with a rectilinear lens, even then, it still doesn't curve at all downward. It doesn't curve. There's no curvature of the Earth. It actually, and the laser's hitting the target 3 foot to 3 foot of. So it's
That's
a
what I'm
real
saying,
globe
bro. You
killer.
whip this,
Oh, oh,
you when you
fantastic.
whip this out, you know what I'm saying? You're like, oh, it's hitting here and it's hitting there on either ends. And the Glober comes and says, well, yeah, of course, the laser's bending down. And then you show him the side on view. I mean, I don't know. I don't know where the argument goes from there.
It goes downhill for the globers, but not literally. Here's the, if anyone wants the image, that's the raw image straight out of Lanolin's camera. It's about 50 megabytes.
Have you
It's in,
ever debated a Glober and used this side on view thing? We
yeah,
could do it
plenty
right
of
now.
times.
We could do it right now. Jake, Pinky, there.
Where you put the raw
They don't want that
footage, Nick?
smoke pickle.
It's the NEF file in the live stream text one, live stream one text.
Carlito ain't the one for this. We need like Jake or
I don't think a side view would help to see the laser arcing or something like that. You don't see the horizon arcing on a side view. The horizon is just that x-axis that you have
yeah, but
from
there's
you to
claims
the.
on there's claims on what the laser's doing. People are saying it's curving downwards. You know what I'm saying? So if you have a side on view with a camera with enough pixels and so on and so forth, you can see if it optically is doing the thing they're claiming it's optically doing or not. That's all.
That's right. The laser would have to be, for this to work on the globe, the laser would have to be bending down for about 14 foot to be able to hit the target at 3 foot. And you can see he's using a really good laser as well that has hardly any what's it called?
With DJ,
The diversion of the beams isn't much over the distance at all. Can hardly see it.
don't go anywhere, and we'll press them on this as soon as we get a Glober in here that knows what they're doing.
Yeah, I do have to get to work in a second, so hopefully a Glober turns up. But yeah,
bro,
I don't.
What gets your priorities straight? What's more important?
Yeah, flat smacking some Globers. It's always more
DJ,
important.
you have a website link for me?
Website link for which?
Yeah.
For this laser, for this test?
Yes.
Oh,
yes.
okay. Yeah, I have Lanolin's YouTube channel. So I'll grab that and I'll put it in the side chat. So he spent about $40,000 in a long period of time setting up his test. He set up he went out with snowmobiles and weather stations, and the guy's been okay. So he's a flat earther, but he decided at the start he's like, I want to become an expert at at debating this topic, but it's too much to be able to learn every single argument of every single point in the topic. So he's like, I'm going to concentrate on camera trickery, right? So he could debunk NASA footage, that kind of thing, and refraction. So he's a deep dive into refraction. So that's why he's gone out with different spectrum lasers. He's gone out with weather stations, and he's measuring the humidity, the temperature, the pressure. And he's got a documentary that he made called The Abomination of Desolation, which I'll post his link in the chat in a minute. It's pretty cool.
Thank you so much. Exactly what I'm searching for. Yeah, really expensive. Yeah, really cool.
Yeah, there's a really good stream. If you look up worldwide debates and just type in worldwide debates Lanolin, it's about a 6-hour stream where he goes over everything with Riggs. He goes over all of the NASA stuff, and then he spends hours going over refraction, lasers. He shows all his footage. He explains everything. Very smart guy. I'll find that link. I'll put that in the side chat as well as the document link. I mean, in the main text chat.
Hey, y'all got a topic. So y'all know. Germany, that's something.
Oh, wait a minute. I want to ask the guy, what's his name? Pickled Mind. What do you think of the TFE thing? What's your perspective on it? Some people think it's fake, so I just wonder what you thought.
Look, I haven't been there. I don't know 100% for myself, but I don't think the arguments that it was fake are very good. I think they're pretty trashy and embarrassing, to be honest.
I agree with that.
Yeah. Well, that's just my opinion, but I haven't seen any convincing evidence when it comes to they didn't have breath. Where's the footprint noise? The noises of the crushing snow in the footprints. It's done in a studio, that kind of thing. I haven't seen anything that's convincing when it comes to that personally. I haven't been there, so I don't know for sure, but I can't see any proof that it was like a studio.
Yeah, nice. I agree with that.
And I saw footage that I couldn't debunk even before they went. If you just look up the 8K time lapse that was out for TFE, and you can't really find any flaws in it. Not that it couldn't be faked, though. Right? I mean, if they were able to fake the moon landings, I'm sure they could fake some Antarctica footage, but I haven't seen it. I'm not claiming that it was because I don't have evidence to back up my claim.
What's up? What's up, Carl? You all set, Andy?
Yeah, that's good. I agree with him.
Yeah, there's not many people are saying it's fake. A couple nutcases here and there.
Yo, shout out to that guy for what he just said. So I appreciate it. But look, check this out, Jerry. I was texting this earlier. I got my head bit off. You're in Australia, right?
Rightfully so, bro. Go ahead.
You're in Australia, right? You got a compass. You aim south, and you walk in that direction. Or you walking in a straight line.
Hold on. You're in Australia. You got a compass. You look at which way is south. You start walking that direction. You toss the compass, or do you always check the compass?
You always check the compass. You keep it south.
Always, like you do a step check the compass. Do a step check the compass.
You ain't even looking up. You just looking down at the compass. You aim it south, and you just walk towards the edge.
All right. Then what?
Are you walking in a straight line?
Not on a globe. No.
No, I'm talking about on a flat Earth.
I might say no also because of magnetic declination.
So what are you walking in?
Like a curvy line, dude. I don't know what the magnetic declination is. I know it gets really bad in the south, and there's bad anomalies somewhere. I would say no. You're not walking in a straight line. I don't have any proof of that. If magnetic declination in the mainstream model is true, you're definitely not. So.
Okay, what if you take a compass, right? Point it south, and then you point in that direction. You hold your finger up, and you point that direction, and then you just walk in that direction. Now, are you walking in a straight line?
So you're gonna check the compass once and then not deviate.
Yeah,
from
you're not
that
deviating.
first, right? Then I would say you're walking it. Well, I mean, bro, you know how hard it is to walk in a straight line. You'd have to like snap a line or something. So it's pretty tough to walk in a straight line.
It's
you always
basically
hear people get lost in the woods. They end up double backing on their one of their previous positions and shit. So
I'm trying to figure out how south works because I guarantee if I told you that we walked north, we'll hit the North Pole, and
bro,
that's
you
a
don't know
straight
how
line.
east works. You don't know how east works, bro. You can't. Don't worry about south yet.
I do know how east works and west.
Okay,
I understand that.
We're standing in a location in North America somewhere. We look at the compass and then head in that direction. Am I going to go around a latitude line or am I going to hit the equator?
Wait, hold on. I said it one more time. We're standing in North America. All right. So the compass is going to be pointing north towards the North Pole.
No.
Okay. Depending on where we're standing, left is going to be east, and right is going to be west, and then south would be opposite of north.
Yeah, I look at the compass. So you're
walking a circle.
Hold on, man. I look at the compass and then I toss that shit and just head in a straight line in the direction the compass was. Do I hit the equator or do I go around the latitude line?
Oh, you'll hit the equator.
All right.
Yeah, because your east and west is relative to north. So it's going to keep pointing north, and then you'll just be walking in a circle. You'll pretty much be walking in a circle.
What's with the south thing, though, bro? What's with the south thing?
Because I'm trying to figure out. So here's the premise, right? I'm trying to figure out which direction is south. Because my understanding was south is opposite of north, right? So if we at the North Pole and we pick a direction and we walk in that direction in a straight line, we're walking south. But I asked earlier, I was like, okay, is that a straight line? And people was like, well, it's not necessarily a straight line and it's not a curved line. I'm like, well, then what the fuck is it? Is it a zigzag? Is it diagonally? Like help me out. And then I got fucking cursed out about it. Well, not cursed out, but people was like, "Oh, Carl, you're stupid. Go to hell." So I'm trying to
No,
figure out South Park.
yeah, I think the whole premise was you were saying it wouldn't work on the flat Earth if a person in Africa tried to go to or went south, and then a person in Australia went south, and they both ended up in Union Glacier. But that's a false premise because if you look, just chat GPT that, they will say, no, they will not both end up in Union Glacier because of magnetic declination.
No, I didn't say Union Glacier. I said Antarctica. I said you would hit Antarctica, and you can get the Union Glacier from there.
No, but
But
your
this
whole
is
point was
my
that
whole
your whole point was that they're going to end up in the same location.
right, which is Antarctica, and you can go to Union Glacier there to make sure you're in Antarctica. But my whole thing was my premise. Like I abandoned that very, very quickly.
So if Antarctica is huge, you're not in the same location just because you're on the continent. Do you understand that?
I understand that, but my thing was okay on a flat map. You go south. Somebody goes south in Australia. Somebody goes south in South America. They're going to be on opposite ends of the Earth. They're not going to be nowhere near each other. You're going to be the farthest. That's the farthest distance you can be from each other. Period. On Earth. So I was trying to figure out what they was telling me now. So I'm trying to figure out okay, then how does South work? And that's where I got to that, and I
Well,
still don't know how.
no one really said no. They just said you would. Your premise is false. You wouldn't go to the same location.
All right, and then I was saying we could test that, right? So we can test that, right?
Did you look at the magnetic declination map that DJ
No,
posted at like
no,
10:55 on the
no,
hour?
no magnetic declination. We don't need magnetic declination for this.
You
We can
absolutely
test.
do because if you're using
All
a
right,
compass, right? How else are you going to
Yeah,
go south?
Carl, if you go stand in one spot, if you go stand in one spot, you're just if magnetic declination is like bad there or something, you point the compass. Dude, I've seen magnetic declination maps where it literally looks like if you're somewhere in the south and your compass is pointing south, you're almost going directly north. Like it's almost a full buck 80. It's crazy.
right. But here's my point. This is why I don't care about magnetic declination. Hear me out. You know how long it takes to fly from California to New York?
But you could be
Think about that for a
pointing
second.
north though. If you pull your compass out and go in that straight line, that line could be like east or something.
I understand that, but do you know how long it takes to fly from California to New York?
Are you on the Concorde? Are you in a Cessna? Are you in a
In an
737?
airplane, just a regular airplane.
Are you in a jet
Flying in a
fighter?
regular airplane.
Are you
You're,
in the
you're, fly-
stealth bomber?
you're flying. You're in a commercial aircraft, a
Are you on
Boeing
the ISS?
757.
My bad.
No, man. You go to the airport when you go to LAX, and you fly from LAX to whatever the fucking airport is in New Orleans, not New Orleans, New York.
I think you're breaking up, Carl. Is it me or him, guys? Like check.
It's him. It's him.
Yeah, it's him. Sorry, it took me a while.
Yeah, I'm flying through the. I'm driving through the country right now. That's why I'm breaking up. I'm in the middle of nowhere. But can you hear me?
I hear you now.
All right. So LAX,
Oh, you're breaking up again, bro. You're breaking up again
commercial
immediately.
aircraft. Gosh.
Get
All right.
somewhere better,
Well, I'll be
Carl.
back
Get
then
somewhere
later.
better. All right, don't try to Terminator me.
I'll come
Just
back.
come back later. All right.
Yeah, yeah, don't forget. All right. Later.
Talking about I'll be back.
else would you expect, regardless of shape? Like, duh, if you understand perspective, there's nothing there that would allude to you, like one way or the other, what the shape is. That's just your preconceived notion being imposed upon what you're seeing in reality and not
Preconceived
understanding
as
an
shit.
alternative.
I don't even know what is his conclusion when he said that. So he saw the building appearing from
He's
top to
throwing
bottom.
shots. He was throwing
Because
shots at us.
I was just throwing a little shot. Just a little love tap.
okay,
That's all.
It was like a
Yeah.
little jab. It was like taking a
Yeah, a
little
little
jab.
bit. Yeah.
okay.
I just wanted to say some shit and then hurry up and change the subject. But anyway,
Just
You just want to throw a little jab and then run.
Well, I was thinking
in
initially
case.
maybe you
Go
started
ahead.
to understand perspective, but I guess that's not the reality of it. You still think
oh
that
wait,
has something to do with shape, I guess.
Jeremy,
So
you were right. All right, so direct flight from LAX to New York, 5 hours, 6 hours. Some of them 5, some of them 6. All right, so we established that. So now I want you to think about this, dog. So you're in Australia and you fly to Union Glacier, and then you go to South America and you fly to Union Glacier, and then you go to South Africa and you fly to Union Glacier, right? One of those flights should on one of those flights you should be flying across the Earth. There's no way all of those flights should be around the same time on a flat map, right?
Bro, what was the question? Were you talking to me that whole time?
Yeah, dude.
We're flying from LA. How long does it take to fly from LAX to New York?
About 6 hours, 5 to 6 hours.
All right. On
Okay, so
certain planes with
that's
certain jet
flying.
streams. Can you change that
Like,
time though? Can we change that?
what you mean change it?
You said 6 hours.
It was like 5 to 6, depending on the plane.
Could we do it in 4? You think?
Maybe pushing it,
To catch
but
a good
maybe,
jet stream?
maybe.
What about 3? Could we
Well,
push it down to
I'll give
3?
you no. I don't think we can get to 3. Maybe if you was flying in a fucking military fucking supersonic jet or
All
some
right.
shit.
So from New York to LAX, it's 5 to 6. You said.
It's 5 to 6.
What about from LAX to New York?
God damn it! Hold on, let me look that up. Let's flip it back. LAX to New York. Hold on. I mean New York to LA.
No, you already said New York to LAX is 5 to 6. What about LAX to New York?
Hold on. I'm swapping them now.
Where are we going? LaGuardia, JFK.
JFK.
It's probably not important.
All right. So JFK to LAX, flying Delta, 6 hours and 16 minutes nonstop.
So that's a very specific time. The other one you had it. So LAX to New York is 6 hours 16 minutes. What's New York to LAX?
No, that was New York to LAX. I'm sorry. Now this is LAX to New York.
All right.
I mean, no, that one up. All right. 5 hours and 23 minutes.
All
5 hours
right.
and 23 minutes. Okay, so we established to fly across the United States, it takes about 5 to 6 hours.
Well, I would just
Okay.
like to note for the record that it's a different time in different directions, but okay.
All right, I'm just saying. Just to fly across
I'm just
the
saying too.
United States
Just it
is
might come
about.
in handy later for me. So I just want to take note right now that it's different
All right.
times in different directions
Right.
for the same distance.
They varied for about 30 minutes.
That was more than 30 minutes. What were your times again?
God damn it, Jeremy. All right, LAX to JFK,
You're
5
trying to
hours,
downplay this
23
because you
minutes.
know this might come in handy for me later.
It's not. I guarantee you it's not, but
Okay.
we're going to do it. All right, so JFK, LAX. I'm sorry. LAX to JFK, 5 hours and 23 minutes. All right. Let's see JFK to
5:23.
LAX.
It was
Okay.
6:16. It's almost a
6:23, so
full.
about an hour. About an hour.
Okay, an hour. An hour
An hour.
difference just from
An hour
across the
difference.
country.
Right. So it take about 5 to 6 hours to fly across the U.S.,
You
depending
think we
on
could
which
get
way you're
that
flying.
number down to 4 and some change?
No,
The 5 hour,
maybe.
the 5 hour
If
and
you
23.
if you switch the plane or you increase the speed, then
No,
probably
same plane. Same plane.
same plane. Nah, not that far down.
You don't think you could shave 23 minutes off?
Maybe.
No, maybe, yes, maybe, I don't know.
Maybe.
Maybe.
I don't know. I'm not an expert, bro. I'm just going
All
off
right,
the
these
flight.
times are really, this is some precise shit though. Go ahead, carry on with your thing.
All
Let's
right,
move
so
forward.
5 to 6 hours to fly across the United States. Are we agreeing there?
Depending on which direction you go in, it'll vary up.
Yeah, that's what I'm talking about. Okay, cool.
And you might
Cool.
be able to shave some times off of that too. So I mean, who knows? It's in the air.
Okay, and that's the time it'll take to fly across a country. One country, the United States.
What's the time?
5 to 6 hours, dude.
You might be able to do it in 4 and some change though.
All right, I'll give you 4. Let's say between 4 and 6. Is that cool?
You're just gonna give me straight up 4? You're a
Yeah, I'm
terrible
giving you 4.
negotiator. Just 4
I'm just
flat. You're a terrible negotiator.
I'm gonna just give it to you, bro. You know why? Because
This is why you're not
I
top
fuck
5,
with you.
bro. Go ahead though. Let's carry on.
This is why I fuck with you. All right. So 4 to 6 hours, and that's flying across the country. All right, cool. Now, think about this for a second. You got Australia and you got South America, which is according to a flat map. Any flat map you look at, they're going to be on opposite sides of the Earth, right?
Sorry, Australia and South America are on opposite sides of Earth.
Yeah, they're on opposite sides.
Like anti
One is
like
on one side, the
exactly.
other on the other one. One's on the top,
I've
one's
seen
on the
them.
bottom.
I've seen one where they're kind of like not really like that. I've seen maps
What
when they're
map?
like kind of like just a quick little shot.
I'm talking about your AE map. On your AE map,
I've
dude.
You haven't seen AE maps where they got it like cocked slightly and it's not that bad from Australia to South America.
No, but all of them you got to fly across the world. On every AE map I've seen, you got to fly across the world. One's at the, you know,
Okay.
on every.
Maybe I don't know. I could swear I've seen some that where it's an AE map, but it's like they'll have them like kind of like smushed up against each other. So like South America and Australia really aren't that far apart. But I mean, I guess carry on.
I haven't seen that one. You would have to show me that one.
Yeah, I don't know. Just
You have
from
to
what
show me
I've
that one.
seen over the years,
All right, so this is why I
I
say I
don't have
need.
it on hand.
So this is why I would need South explained, because under those circumstances, if I showed you flights going south from South America and flights going south from Australia, and they landed in the same general area and they got there in close times, then you have to admit that's impossible.
Whoa. What the fuck? Hold on. What happened? You
If I
go
showed you
south
a
from
flight
South
going
America and
south
south
from
from Australia.
Australia and they landed near each other in the same place,
Okay.
and they had
Okay.
similar times of flight, then you would have to admit that's impossible.
That is absolutely not okay. You have 2 points on flat Earth. Uh, you make a you make an equal distant line between those 2 points. Now we got a triangle. Why is that impossible?
Because they have to go south.
But the same times and the distances and shit, they could do that, right?
No, because if you go south from South America and south from Australia, you're going to end up on two opposite ends of the earth.
South according to what?
According to a freaking compass or a map or
We just
south. That's
went
what I'm
through
trying
Yeah,
to
that
figure
but
out how
none
far
of
declination.
none of
it
them
is.
flights go south though, man. They go east and west, bro.
There's that too. I mean, yeah, but we went over the declination thing, dude. You could be standing
Except for the
somewhere.
ones that go to Antarctica.
You could be standing somewhere south. Your compass will say south, but it's actually fucking east or something. Like magnetic. Look at a magnetic declination map, dude. It gets wonky in the south. Bad. Real
Like almost
bad.
180 degrees wonky. Like it says
That's what I'm
south, but you're
saying,
actually
bro.
facing
Yeah.
north, kind of stuff.
It's
I'm getting
nuts.
ready to take a
Yo, it's
15.
nuts.
I'm getting ready to take a 15-hour flight. I don't know what that's going to prove,
No, so
but I'm
okay.
taking one.
So
Oh, you're
basically, what
about to
y'all
debunk
saying is,
flat earth.
so
Yeah,
basically, what
right.
y'all saying, basically, what y'all saying is that we can't verify if we're going south because of magnetic declination.
Have you looked at the magnetic declination maps? Have you seen the variances? Do you think that
Yeah,
the
and they
AE
don't
map
vary.
or the globe map is? Do you think there's an adjustment for magnetic declination on those maps?
Yeah, the closer you get to the magnetic South Pole, yeah, but they don't vary the way y'all varying it. Only when you're like very close to the magnetic South Pole, but not when you're just in Australia. You're fine. You can use a compass, totally fine. Same thing with South America.
Sure, but you're talking about leaving the place, right? And that's when you start to get into magnetic declination anomalies.
Right, when you get
And it's
very
not
close to
just
the
around the magnetic South Pole, by the way. Maybe look one up, take a gander at it before you start
I
to
already
talk
did.
as though you know what you're talking about.
I already did. You have slight variances for sure. The extreme ones y'all talking
Flight?
about 180 degrees and all of that is very close to the magnetic South Pole. That's a fact.
Yeah. So these flights that you're talking about, where are those close to?
They're not. No, I'm talking about extremely close. Not that. Not the distance between fucking Australia and Antarctica, dude. And then even if I was to grant you that, then
And the
you would need to
variants
have
aren't just
multiple.
right next to the magnetic South Pole.
Napalm. Even if I granted you that, you would need multiple magnetic South Poles in order for that to work.
Yeah, that's a possibility. Have you proven that it's not?
Oh, so now we have. So we got magnetic South Poles all around the ring.
I don't know. You've
Besides
been
the
out there
one.
testing them? You've been out there testing them, bro?
I'm answering the question.
No, you're the one who posed it.
Then you're making the claim, bro. You're saying it's magnetic
I never
declination.
made him make. Repeat my claim back to me.
Excuse me. I'm sorry. Your claim is that we can't tell if we're going south from Australia and South America because of magnetic declination. We could be going east.
Well, I'll accept that if you can go back and clip that and play it back. That was my claim.
That's
But
what you
that is not.
insinuated.
Oh, so you're saying
You're an
your
insinuator.
interpretation? Yeah, your interpretation of my words is somehow reality.
I mean, that's what you're saying. Should I not take what you're saying into account? That's what you're saying. I'm saying we could fly south
That
from
is not what I
Australia.
said.
Okay, so can we fly
I
south?
said there are times with magnetic declination that it could be up to 180 degrees variance. Now,
Right. Then
everything else you put after that's on you.
right, and that's very close to the magnetic South Pole. That's when you have all
That's your
this
claim.
extreme declination
So
that you're
there's no
talking about. No, that's
there's
not
no
my
place to
claim,
say
bro.
from.
That's the observed reality of it. The observed reality is that when you get close to the magnetic South Pole, that's when you start having these extreme instances of magnetic declination that can spin around 180 degrees and all the other extra shit.
In the south, and you said your flight paths that you were talking about were going south from Australia and
Right?
south from South America, right? That's your claim. So do
Right.
those flight paths come close at all to the magnetic South Pole?
They do.
Oh, well, there you go.
Right, but that makes sense on a globe. It doesn't make sense on a flat Earth unless you have multiple magnetic South Poles. So I'm asking you, are there
No.
multiple magnetic South Poles?
That's what they claim
See-
on the globe. They claim
Napalm, you
there's
need to
two.
have that answer
There's
right
one.
now. Are there multiple
No, they claim
magnetic South
two.
poles,
They claim
Napalm? I
two
want you to know.
magnetic
Have you
South
checked?
poles.
Yeah, I
You
haven't been
would
down
need
there.
you would need magnetic South Poles all the way around the ring. That's what I'm saying. Because you can fly south from Australia, you can fly south from South America, you can fly south from South Africa.
Where do you
And
think that the magnetic South poles are on the globe? You didn't know that there was two, right? They claim that there's two.
it's somewhere over water. The one in the south. It's like off the coast of Antarctica.
But you said that there's only one. Is that the one that you're talking about?
No, I'm saying that on a flat Earth you would need multiple. You would need more than two. You're telling me there's two. I'm telling you, on a flat Earth, in order for this to make sense, you would need an
But you're
infinite
just
amount going around the ring.
well, I think you're making a few assumptions.
All right. I'm not making a few assumptions.
You should what I would recommend you do, to make the argument a little more sound, is to actually get the flight paths of the flights that you're specifically talking about right? And then form it together in a little presentation where you can say, okay, this is the exact flight path I'm talking about. This is what it's claimed to do, and and then we could actually go over it, and we could look at the magnetic field line map and all of that sort of thing, and actually have some data to work with instead of
Yeah, but
just kind of hypothetical.
before I go into all of that, I want to make sure we get the premise right first. Then once I can prove that, then I don't want you to be able to walk back your premise. So that's why I'm asking you how South works before I do this. So I'm just asking.
He's trying to
If
set
you
a
fly
4 hour
south,
long. This is a 4 hour long trap he's trying to set here. Go ahead, Carl.
it's not a trap. I'm just asking you a simple question. The way that the South works on a flat map is they all spread out from each other. Am I lying?
On the AE map,
On any map, any flat map, South is opposite of North, and if North is in the center, then all points away from North would be South, right?
Are you just talking about lat long
where
maps,
where
which are spherical coordinate system projections?
I'm talking
I mean,
about in
what map do
reality.
you
I'm
have
talking about
north in
on
the
Earth.
center? What map do you have north on the center of? It sounds like you're talking. You said you weren't talking about the AE map, but it sounded like you were talking
I'm
about the
talking
AE
about
map
in
when you said it.
reality. In reality, if you stand, is there a North Pole in your world?
A North Pole,
Yeah, North Pole. Is there a North Pole in your
like in
world
the sky or on the ground?
on the ground?
I mean, you got to be more specific. Like, what does that actually entail? The pole part. Like, is there one spot we could all walk to and we're
Oh,
all up at this? If we all went north, would we all be holding hands at the same spot? You're saying?
yeah. If everybody went north, will we meet up at a point, and will we call that point the North Pole?
I mean, I think so, maybe, but I mean, you'd have to check. I'm gonna have Napalm check it after he does the south thing for you.
Okay. So
Are you
if we
talking
all meet
about
up
the
at a point,
magnetic north, though? Just quickly, are you talking about the magnetic north, which is not this where the GP is for the Polaris for the celestial north pole ground position? That's a different location than the
He's talking
magnetic
about the
north pole. Which one?
presumed polar axis. I mean, why you guys are.
Well, that's not what your compass is going to take you to.
I think y'all know what I'm talking about. I think y'all just don't want to say it because you know what it means. I think you know what it means.
No, I'm asking you questions about it. Simple questions,
All right, let
because
me ask you a question.
there's different
What
right.
what's
There's
on the
magnetic
Polaris?
north, there's true north, etc. So I'm asking you which north pole you're
I'm not
talking
talking about
about.
compass. I'm talking about we all
Because
walk
you didn't
towards
know that there were
Polaris.
two magnetic south poles a minute ago, so I'm guessing you don't know that much about magnetic declination.
Only one. There's only one main magnetic South Pole. I don't know about the second, but I don't care about that one because I'm talking about walking towards Polaris.
That's my
So if
point,
we
though.
all
Like you
walk,
don't know
if we
you can't
all,
stillman the basics of the globe. That's why I'm asking you questions so you can
oh my
clarify.
God.
Because I don't think that you've looked into it enough to be using it as a debate
No, I've
argument.
looked into it. I've looked into it, and it's a very simple premise. If we all walk towards Polaris, will we all run into the same spot? Very simple. This is
Who
not complicated.
validated that? Who validated that? Who even validated that the GP of Polaris is at a particular location at that
Okay,
Polaris,
so
right?
we
At
all walk towards.
that the North
Okay.
Pole on the Earth, right, is at the zenith. That Polaris is at the zenith of that point.
You
Who
don't want to.
validated that?
So you don't
Maybe
want to
it's
answer the question.
true, but who actually tested that?
Yeah, you're not
So
even
you
allowed
don't
to
want.
go there. That's the problem.
So you're not going to answer the question.
Well, I'm asking you like questions about what you're claiming, right? So if you claim things, then I'm going to ask you questions about the things that you're claiming.
I'm not
And
claiming anything. I'm asking
you
you.
did. Well, okay. I gave you an answer. I said nobody's done that to confirm what you're suggesting.
So you don't know. Is your answer?
My question is, I don't know, and you don't know. Yeah.
Okay,
That's my
so we
answer.
don't know if there's a North Pole. Is what you're saying?
It's
Well,
presumed,
depends what you
but
mean
I've
by
never
North Pole.
confirmed it.
I'm just
Yeah.
asking, bro. Is there a North Pole?
There's a
Is
celestial
there a
point
ice
in the sky.
North
There's
Pole?
a celestial pole in the north. That I can agree
Is
on.
there a
If you
landmass?
know,
Is there a landmass there with a lot of ice?
I don't know. Have you tested that? Who checked?
I mean, people go there. People live there.
Well, isn't there no land there on the globe model? It's just a
In the
spot
North
in the
Pole?
ocean. Yeah, the
No.
North
You're
Pole.
talking
What
about
do you
the
think?
magnetic
Santa's
North
at the North
Pole.
Pole or something?
I'm not talking about the magnetic North Pole. I mean, I'm not talking about the magnetic North Pole.
Okay, so grab me the map, the globe map, and point to where you're talking about.
Okay, look at a
Just-
globe. Touch the top of it. That's the North Pole. Look at a AE map. Point to the middle of it. There's an ice there.
What's the point though,
That's the North Pole.
Carlito? What's your point?
Okay, so I'm trying to see if we all travel north, will we get to that point? And everybody's like not answering the question.
Okay, I'll answer yes. Now what?
Okay, okay. Now is opposite of that point south.
No.
Okay. And then what is the opposite of that point?
I think you said it
What is,
earlier.
what is south?
South is every other direction other than north.
Okay, so if we're standing, if we all walk north and we get to one point, and then we turn around and we walk the opposite direction, are we walking south?
Yes.
And does south go in all directions from that point?
Well, this is how I presume it to be on a flat Earth, and I would say yes.
Okay, so that means that Australia and South America would be on the opposite side of the world.
From what?
Right? From north.
You said
Me and
Australia
Jeremy
and what?
if me and Jeremy were standing back to back at the North Pole and we started walking away from each other, we both would be walking south. One of us,
Yes.
if we could walk on water, one of us would hit Australia, the other one would hit South America.
Depending on the
If Jeremy
direction.
walked south,
Depending on the direction you went.
what do you mean depending on the direction I went? What do you
So
mean? I just told you the
so
direction I went.
you're going two different directions apart from one another. You're standing back to back at the North Pole,
Uh-huh.
and you're going two different directions.
Uh-huh.
Great. So the South Pole is an outer ring. The North Pole is a center point.
Right, exactly. Okay, right. So we can test that because Jeremy, when he walks south, he'll hit the ring, and then when I walk south, I'll hit the ring, and we would be on opposite ends of the earth because it's a ring.
Okay.
Okay, so we can test that, right?
I don't know. Can we? I mean, I don't think we can go past the 60-second parallel south, and I don't think you can go completely to the center of north.
But we can go to
Those
Union
areas
Glacier,
are.
can we? Can we go to
What's
Union
that?
Glacier? We can go to Union Glacier, right?
Well, aside from like legal boundaries, like sure, theoretically, yes.
Do you think the TFE was fake?
No, not necessarily.
Okay, so they went to Union Glacier. Do you think people that run the marathons, do they go to Union Glacier?
Okay.
Okay, so if one person flew to Union Glacier from Chile and the other person flew from Union Glacier from Melbourne, don't you think that the flights should be vastly different? One should be like 5, 6 hours long, and the other one should be like 19 hours long. Don't you think? Or
I
no?
mean,
I think
I'm
just
not
way
looking
fast.
at the map, but I would just assuming that they're different distances apart. Sure. I mean, I don't see what the point is, what the problem is.
Right, so we would have to check that, right? So if they're not, if they're similar times, then that means that they can't be on opposite ends of the Earth, which would mean that it's not flat.
If there's another time,
Yeah. If you took
No,
if somebody took
it's flat. It's flat, and it will remain flat till the moment that those people who were back to back in the North Pole will meet each other in the South Pole at the center of that ball that you are claiming. If those people never meet each other, yeah, it's not a
no,
ball.
I'm saying, y'all, we
Yeah,
established
I
that.
understand what you're saying.
Oh my God. I don't know why y'all making this so complicated. We already established that Melbourne, Australia, and fucking Punta Arenas, South America, should be on opposite ends of the Earth. So if you
It's
just take two people from those two places and you told them to fly south and see where they ended up, if both of them end up at Union Glacier, then there is no way that the Earth could be flat.
No, you pointing to
no,
a
no,
direction. That's just stupid,
no.
bro. What you mean? You're telling, oh, go to Union Glacier. No, what you have to go is go opposite directions. You go south, you go south the other way. But right now, where you're telling me, hey, go to this location
Yeah,
to
they
a
would have to
point.
fly south.
Yeah, that's not go. That's That's you're just dude. How okay? I'm you know what? I'm
Yeah,
just gonna
I
stop.
told him that. I told him that
bro.
you don't need to bring any specific location. You just unleash those two people back to back from each other on the North Pole, and they will meet each other. If the Earth is a ball, they will meet each other at a certain point in the South Pole
That's what
without
I'm
any
saying.
specific. Nice. They
Yeah, but you're
won't.
not saying that. You're saying go to a location. It's like saying go to
No.
California from China and go to California from Ecuador. And if y'all made up in the same place, then the Earth is a ball. Get the fuck out of here, bro.
Oh,
That's
listen, bro. If
it's
one
just
person is
stupid.
flying, if one person is flying south from Melbourne, Australia, and the other person is flying south from freaking Punta Arenas, and both of them end up close to Union Glacier, bro, they should be getting
No,
further
well,
apart.
that's not. That's dude. Now you're saying close to Union Glacier. Well, first you were saying if they both go to Union Glacier, they fly to. That means the Earth is a ball. That's not the way it works because you're trying to say go to this location. Now, what you got to do is go south. You go south. You go south. If we meet up in the middle of wherever we land at, there you
You
go.
don't have
Then
to.
there is
You
a.
don't have to meet up in the middle, dude. Listen, bro. There's two exclusive claims here. The Globe claims that Antarctica is a continent. The Flat Earth claims that Antarctica is a ring that goes all the way around the Earth.
Yeah, but
So
they
all
when
you
you
have to
fly
do is
False.
see what
False.
Antarctica is.
when you fly
Oh,
from Melbourne to Union Glacier, you're not going
mhm.
straight south. You're going southwest.
Yeah, you got to understand that the thing is, Carlito, is nobody travels straight as a crow flies. Everybody takes a curved path when they
But even if
travel
you
long
curve, it's
distance.
the distance that
Oh,
we're
bro, can you
taking.
hear
It's
me?
not.
Can you hear me? Mic check.
I can hear you. I'm sorry.
Okay. So if you're to understand that nobody travels straight as a crow flies, everybody's taking a curved path, then and you understand this, then what are you saying?
You look at the time, the distance. That's why I asked how long it takes to fly across America. 6 hours.
How are
Okay,
you
that's
going to get an accurate distance if you're not going straight? When you
you
measure
know how you
things,
get
the
an accurate
distance to
distance.
things, do you measure it curved or do you measure it straight?
Measure it any direction you want to. What are you talking
No, we
about?
don't. We don't measure things, right? With a curve. Like that's not how we measure distance. We measure distance from A to B.
Yeah,
Wait,
bro.
so if
Like
you
But
like
you're
what
not traveling
Daislow's
from A to
oh
B.
saying. What Daislow's saying right now is like, if you were to go to your friend's house, right?
mm-hmm,
But there was like a little lake in between you, so you had to go all the way around the lake in a huge arc or
mm-hmm.
something. You wouldn't say that's the distance to your friend's house, and is that arc that you took?
But you would say that's the distance that you traveled.
Okay, but that's irrelevant.
Yeah,
Yeah.
no, it's very relevant because on one you would have to travel across the whole world, and on the other one you have to travel just a little bit. So if they get there around the same time, then how in the hell can you say? Like, I'm not understanding why this is so difficult.
Bro, you're not
One
even
flight
getting
should be
you're not even
way
getting to the
longer than the
same
other one.
time. Carl, it's not even taking you the same time to get to the same location. You go from New York to LA, what's the time? And then what's the time from LA to New York? Those aren't even the same time. So I don't know like what you're
Yeah, but
trying to
there's
use
only,
this for.
but Jeremy,
Remember
there's
when you
only
said
like there's
I
only an
wasn't
hour
going to be able
difference.
to use this? Remember when you said I
You
wasn't going to be able to
can't,
use it? I'm using it right
you
now.
can't, you can't because it's
I'm
an hour
doing it right
difference.
now.
It's an hour difference. It's an
Or
hour
2
difference,
hours.
bro.
You gave me 4 hours.
I'll give you four
Remember?
hours. I'll give
Yeah,
you a
and one was
4 hour
6,
difference.
one was 6, one was 4. That's a 2 hour difference. Admittedly, your guys aren't the point Dyslow made about not traveling in a straight line. You guys admit that the pilots are making Coriolis corrections, albeit ever so slightly, but that means they're not going in a straight left or right path. You got major issues with this, my man. Major issues.
I think you're trying to make it a major issue. I
No,
don't
I'm
mind
just
giving
saying your
you a
shit's
2 hour
all fucking
difference.
wonky, bro. Your shit's all
How?
crazy.
Man? How? One flight would have to fly across the whole globe. Well, not globe. Well, one flight would have
Here's
to
how
fly
your
across
shit's
the whole
wonky.
map.
Here's how your
Okay.
shit's wonky. You're trying to use this time thing. You're not even
Mm-hmm.
going back and forth from the same 2 points in the same time. So there's that,
Right.
right? And for
Okay.
B, they're admittedly not going in a straight line. So there's that. Like this
Okay.
is all over the place. This is nuttier than squirrel poop.
Google her.
No,
I'm looking at it
I'm
right
not
now.
doubting you, but that's ridiculous.
Bro, I'm looking at it right now. There's one magnetic South Pole. Then you have a geographical South Pole, which is a place, right? Then you have the geomagnetic South Pole, which is a theoretical point, not a real point, and it's calculated based on the magnetic field. And then you have the South Pole of inaccessibility, like I said, which is just a point on the Antarctic continent farthest from all the coastlines.
Dicelo, post what you're talking about because that's ridiculous. A magnet has a north and a south. Single, one of each.
Yeah, but you don't know how many magnets we're dealing with on Earth. It could be more than one magnet.
Well, that's a different story. Yeah.
That's what I mean. We're talking about on Earth. So
You know, Jeremy, I'm disappointed in you dropping down. It used to be you,
why?
Geo, and then SC, but now SC is number 2.
You don't
Geo's
even
number
have
1.
Witsit on there.
You're like
You don't have
5.
Witsit in your top 3.
Nah, Winston not in my top 3.
Wow,
He is in my top 5 though.
your list is crazy. You think you're in the top 5 Globers though, so that's your list is all fucking crazy.
No, I was just asking if I was in yours.
You put
And
yourself
while
right
we're on
next to
this,
Kosho. Go ahead, Essie.
Me and Coach are
while
there.
we're on this
No,
magnetic
hell
thing,
no. Go ahead,
I brought
Essie.
this up. Yeah, while we're on this magnetic thing, right? I brought this up before. Has anybody ever wondered why the compass never flips? Anywhere on Earth, it always points north. Has anybody ever like contemplated that?
Well, they say
Yeah,
it flips, right?
they say it flips.
Where? No, they don't say it flips anywhere. No, where do they say it flips?
When you go through the magnetic, you gotta go through the magnetic pole, South Pole.
No, it
Why would
never
why
flips.
would it
You have
flip?
people in the South Pole showing it always pointing north.
No. It's only gonna
No, they
point in
say
one
there's
direction.
a region you got to go through. There's the region. It's like off the South Pole. That is the magnetic South Pole. That when you go through that, it should be pointing. Like if you were to go in a straight line, they say it would be pointing behind you afterwards, right?
Well, they say that, but I've never seen any. First of all, I haven't heard that they say it, and I've never seen a compass pointing anywhere but north.
Yeah, because it aligns with the magnetic field lines. So it's not going to flip. It's just going to always point north. And then when you get close to the pole, it's going to start doing crazy shit like spin and all this other type of shit. But it's always going to point north.
Well, except that magnets don't work that way, and compasses they don't work that way. They don't start going crazy, and there's a certain point where the compass flips.
No, if you stand close to the source, then it's going to start acting wonky.
Look, Carlito, get a magnet and get a compass and move it around the magnet, and you'll see it flips. There's no way around that.
Yeah, because you're thinking about a magnet. You're talking about like a bar magnet, right?
Well, that's what they say that your pseudo Earth is. It's like a bar magnet,
Right. So if you lay
right?
a bar magnet on the table and then you take a compass and you move it around, then yeah, it's going to flip. But that's not how that's not how the Earth. You got to think about it. In order to make it like how you saying it, you'll have to take a big styrofoam ball, and then you'll have to stick the magnet through it.
No, not really. Why? In your
Because that's
model,
how.
pseudo model, it claims it's like a bar magnet that runs north to south, right? That's why the
Right.
compass works,
Hmm.
right?
Yeah.
Okay. So there's no magic to a magnet. Well, there is magic. I mean, I'm not talking about how the magnet works itself. I'm talking about how the magnet works with a compass. There's no getting around it. When you move closer to each pole, the compass will flip. Try it. There's no getting around that. Now, unless you think the Earth is special and doesn't behave like a magnet, that's a whole different story. But you understand what I'm saying?
Yeah, I understand. No special. So if you take a magnet and you lay it down on your kitchen table, and you get a magnet and you go around it, it'll flip, right? But you got the magnet laying flat on the table. That's not how Earth's magnet is. You have to take the magnet, take the bar magnet, and impel it through a ball to where the north is at the top and the south is at the bottom. And then take your
So
your compass and move it around the ball.
okay, so according to the way you're thinking, is the magnet aligned horizontal or vertical on Earth?
It'll be vertical and it goes out.
It'll be vertical.
Yeah, like top to bottom. The top will be the north, the bottom will be the south. You put the north at the top, put the south at the bottom, and it'll radiate outward.
Okay, so it still has to behave in the fashion that I'm saying. There's no way around that. There's a point. There has to be a point on Earth that the compass will flip. There's no
What
way
point?
around that. And so far, there is no such point on Earth. Now,
Why would it flip?
unless we're dealing with a monopole magnet, which we know it doesn't exist, you have some splaining to do. And this is not a flat Earth versus globe thing. This is everybody. This concerns everybody.
Why would it flip, Essie?
I just explained to you how a magnet works and how a compass works. If you're
Right.
closer to one pole or the other, the compass flips. I told you. Take a bar magnet and see for yourself.
Right. Wouldn't it point towards the north pole of it? Well, actually, it's like reversed. So
Bro, do
actually,
you
the
have a
south pole
magnet
is at the top.
and a compass?
Yeah, but I'm
Do you have a
saying
magnet?
actually it's reversed. So the southern one would be at the top, and then that would point north. But anyway, but what I'm saying is, if you took the bar magnet, you're thinking of a bar magnet lying on a table, dude. That's why you think it should flip. I'm assuming you think it should flip at the equator because you're thinking about it being on a table instead of thinking about it being through the sphere. And you on the
Wherever it
surface
is,
of
right?
the sphere.
Your compass is picking up the reading, right? Regardless of how you imagine this in your mind, right? There has to be a point where it flips. I don't know if you understand that, right? There's no way around that. If you think the Earth is a bar magnet, then there has to be a point where the compass has to flip. Be it some say at the equator, some say at the North Pole, but it doesn't happen. The only thing we have is they say there's a military video flying over the North Pole, and it says it goes crazy and wonky. That's not how things behave. That's not how it works.
I think, you know what? We should try it. We should get us a bar magnet and a big styrofoam ball, and we should stick the magnet through the ball and get a compass and move it around and see what happens.
Try it. Try it. You're going to be shocked. Whether you stick it through a ball, wherever you stick it through, you're going to see that compass flip. There's no way around it. It's physically impossible for something else to happen. It has to flip. That's how magnets work. That's how magnetic attraction works. There's no way around that.
All right. Well, I'm willing to try that, and I'll
Please
report back
try
to
it.
you.
Try it and film it and see for yourself.
I'll report back to you, fine sir, my findings. Now, let me ask you a question. Let's see if you're a top thing, and we're gonna keep it very simple. I'm gonna ask it quick because I've been going over this for 2 hours. Right, north, right, is towards the center, correct?
What do you mean
That's it.
north is towards the center?
If everybody on Earth, the Earth is flat now. We're on a flat Earth. If everybody walks north, we're all going to meet up in the center of flat Earth, right?
You mean geographic or magnetic? Which north are you talking about?
If we all walk towards Polaris,
Well,
We'll all be
yeah,
stopped.
sure.
We'll all be stopped by
okay,
Russia.
okay. Assuming we don't get stopped by Russia or shot, we would all end up in the North Pole. Okay, so now we're all under Polaris. We turn around and everybody walks in opposite directions, right? We're walking south, right? Essie?
Okay.
All right, are we walking in a straight line?
I don't know. Are you?
I'm asking.
You're asking me. You're asking me of a shape that I don't claim. You're asking me to make a prediction on that, right?
No,
I don't get it.
I'm saying if it was flat. I'm not asking you to claim something. We're just doing a thought experiment. If it was flat and north is one direction, if we turn around and we walk the opposite direction, we'll be walking in a straight line, right?
I guess, yeah.
All away from each other, right?
Well, yeah, if you picture a pizza disc, if that's what you're talking about a disc, a flat disc.
I'm just saying any type of flat. I don't care what shape it is. It could be a star, a disc, a triangle, whatever shape you want it to be. If north is in the center, in the middle, and south is opposite of that, if everybody was in the middle and walked away in different directions, we will all be walking south, but we would all be walking in different directions away from each other.
Right, in that scenario, but I don't claim that. Let's be straight out, right? That's not anything that I claim. But yeah, obviously, if you're on a pizza dish and north is in the center and south is all around, you'd be walking in different directions. Duh.
All right, thank you. And I'm happy that you put the duh on there. I hope all the other people who've been arguing with me for 3 hours telling me you could be walking in any fucking direction just heard that duh.
Yeah, but make understand one thing. I don't claim that. That's not my idea, right? It's just
I know, I appreciate it. I'm not saying
yeah.
it is. I was just saying. I was asking people that, and they were saying, oh, you could be walking straight, or you could be walking into the left, or you could be walking to the, you know what I'm saying? It's like, damn, dog. It's not that complicated.
Well, let me ask you something then. On your ball, right? When does north become south?
When does north become south? When you cross over the North Pole?
You're walking north, right?
Yeah.
You're walking north. So
Yeah.
at a point, north becomes south in your pseudo model.
Yeah. when you walk over the North Pole, when you cross the North Pole.
So you could be walking in one direction, and then from that it just turns to another cardinal direction. But you're still going in one straight line, right?
Yep.
Okay.
You're going in a circle, a great circle.
Let me ask you another thing. What time is it at the North Pole?
What time is it at the North Pole? Like right now?
Yeah.
I'm at North Pole.
You think you can recreate that in reality? Since we're
Why would it
playing
melt?
the model game, right?
Why would it melt though?
Well, think about it. You think it's physically possible to have a frozen ball with one heat source and only heat the center of it? Do you think you can recreate that?
Yeah, because it's tilted. So all points on it's a sphere, so the whole thing isn't being heated evenly. You got the middle, which is getting the most direct sunlight, which is why it's the hottest on the equator. And then you got the tops and the bottom, where the sunlight is just skimming it. And then you got ice there, which is reflecting a lot of that heat. So it's going to be cold there.
So you think just by tilting it, so you think like you have a campfire and you have a frozen ball, just by tilting it, you think you can just melt the center of it?
Well, I mean, that's going to be a little different because you got to understand that if we're sitting by a campfire, we're on Earth and we're surrounded by an atmosphere, right? So you got the
Yeah, but you forget,
atmosphere that's going to be heating it. But the Earth isn't in the atmosphere. The Earth is in space.
bro, but you're forgetting something. You're forgetting conduction.
Okay.
Conduction
What
from
about it?
what? Yeah. Did you forget your molten core? How do you have a molten core right next to a sun that's supposed to be 1.3 million times bigger than the Earth? How do you have that and still have ice caps?
So what are you saying that the molten core should just come up and just heat the whole thing and melt everything and burn everybody?
Over millions of years, you should have conduction, or heat gets
Right.
transferred through the mass of the Earth. Plus,
No, it's
not only do you have
insulated.
the sun, but you have the molten core, bro.
Try to do it.
That's what I'm saying. You can't. I can't create. I don't have an anti-gravity device, so I can't make. I don't have an object big enough to have its own gravitational field. So that's like impossible. You're telling me to do something impossible.
Okay, then there's no evidence for it. Thanks. That's all I want to
Exactly.
know.
How is there no evidence for it if you can see it? That's my
That's
thing.
what your model will claim. Yeah, claiming. That's it. Yeah, no evidence, no scientific method, no evidence is an abstract concept. Period. So that's
But
it.
you can see it though. That's my point. You can see it. So you saying there's no evidence?
You can
You
see
can see it
gravity.
though.
Oh, so that's a new one. You can see gravity.
No, but you can see. You can see the Earth is surrounded by an atmosphere in a vacuum. You can see that.
Okay, then provide an experiment that shows that vacuum can coexist with a pressurized system without a
Oh,
barrier.
fuck
Please,
me.
go ahead.
Well, I
Okay,
wouldn't.
so
First of all,
take
before you get past his original claim there that you can see it, right? That's in question to begin with, right?
Wow. How was that a question?
Have you experienced that, Carl?
I've seen it, yeah. You can see it
Oh,
too.
you have? So
Yeah.
how far up did you have to go to see that in its entirety?
To see vacuum?
When did you do it? Yeah.
To see vacuum, you can get in a plane.
No. You said we see it. We see the entirety. We see that it exists with an atmosphere inside a vacuum. And I'm asking you when
Right.
you experience that.
Yes, when you fly an airplane.
No, you can't. You're telling me you can see the entirety.
Well, the Earth, no. That's not the claim I'm making right now. I'm talking about vacuum
Oh,
next to
so the claim is
pressurized system.
which okay, and your claim is that the Earth is exactly that, right?
Right. So when you're at sea level,
So you are
right?
talking about it. So you're talking about it, but you're not talking about it.
We're talking about. So what are you talking about? You're talking about the curvature of the Earth, or are we talking about pressurized system? Which one we're talking about?
We're talking about that pressurized system in a vacuum, and you say that we see it,
Okay,
and
and you
your
can
claim
see
is
it.
that we see it with Earth. And I
Yeah, you
said,
see it.
okay, that's cool, Carl. Give me the time and date in which you saw that. You say you went up in an airplane, but you're not. You're
You can
just
see it in that plane.
experiencing a small portion of something. So you don't experience that. You've never experienced that.
How don't you experience low pressure next to high pressure? How are you not experiencing that? When you're on the ground, you're in a high pressure system. And you go up in an
Yeah,
airplane, now you all of a sudden
100%.
you're in a
Yep.
low pressure. You're
I
in a
never
low
made
pressure
that.
system.
I never made a claim that we didn't.
Okay, so
Your
what are you talking about?
claim, I'm blowing up your spot when you're making the claim that we see this entirety. We see this ball that has an atmosphere in a near perfect vacuum. You say that we
I
see
didn't
that.
say that.
We don't.
I didn't say that. I didn't
Okay,
say
so then
that.
that's not your claim. So you're not claiming that then?
No, not then. I wasn't claiming it. You can see that, but that's not what I was talking about just then. Just then, I was
That's
talking
it. That's
about
SE's point is about making that on a smaller scale. And you say that we see it, we experience it, but we don't.
you
It's
experience
speculation.
being inside of an atmosphere adjacent to a vacuum. You can see that.
No, I can't.
How can't you?
I experience everything within the atmosphere. Everything.
Okay,
The
so
atmosphere
if you
extends to the moon. I've never been past the moon. The atmosphere extends to the moon. So no, I don't experience that.
it does, but the vacuum starts way closer than that, doesn't it? In my model, does the vacuum start at the moon or before?
No. Well, give me, first of all, vacuum would have to deal with where you claim in a pressure system that vacuum starts. So give me pressure in which that
No,
starts, and then we can talk.
vacuum in this situation is a relationship to something else. So that's why when you see like those movies and shit where they poke a hole into a plane and everybody gets sucked out, that's because the plane
Oh, so that's the
is
vacuum. So
flying.
within the Earth's atmosphere, so even below the Kármán line, you're in the
That can
vacuum?
be considered.
Is that your
That can
claim?
be considered. That can be considered a vacuum. Yeah.
Okay. All right, cool.
Are you guys denying the pressure gradient? Are we denying the pressure gradient
No,
today?
nobody is. Nobody is. Nobody made that claim.
So where does the pressure gradient stop then?
That's a good question.
Exactly. That's my point. So you got a high pressure system sitting on top. You got a high pressure system with a low pressure system right there, and that's the thing I'm saying
No.
you can see. And that's the thing
No,
you're telling
no,
me it's not.
you go from
No.
you go from high pressure to gradually to low pressure. So
Right.
where do you think the pressure would stop then?
Well, yeah, no, I'm not making that claim, right? So it's just a gradient. He's claiming that all of that could be considered a vacuum, right? What I'm experiencing right now, one atmosphere could be considered a vacuum compared to something that is of higher pressure.
It's dumb, but okay.
That's his claim, right? So if we're talking about that and we're talking about a gradient, that's fine. We experience high and low pressure differentials here on the surface at one atmosphere. We experience fluctuations in that of high and low pressure systems. That's what causes our weather.
So if you go, are you saying that when you go up in altitude, there is no pressure gradient?
No, nobody's making that claim. Karl made the claim that he has gone up and he's experienced from a vacuum something that has an atmosphere. So I'm asking him where he experienced that, what the height was. He said it's just in an airplane. So is that your claim?
So the
as
pressure
well?
is lower. The pressure is lower up there, isn't it?
That wasn't his claim.
Oh,
Yes, it was. That was my claim. That's why when you see an airplane
So
with a hole
if
in
I
it,
go up
everybody
on
gets
my roof, the pressure's lower. If I go up on a 2-story building, the pressure's lower. So his claim means absolutely nothing. So what he's trying to claim here means absolutely nothing because we're talking about creating on a smaller scale what we experience with Earth, right? So it's going back to SE. His claim is put it in a vacuum chamber and then experience these heat differentials that you're talking about, where you can have frost and frozen portions on the outside. You can have a molten iron, you can have a molten inside, and you have no heat transfer between the two of them, right?
What?
And Karl said, we see it, we
In a
experience
bucket,
it.
in a bucket in a lab, right? Got it.
Yeah, because otherwise it's just speculation. Like, I don't have to believe
in a
the
bucket in a
bullshit
lab.
story of it being a ball, that we can experience it from space
measure it.
because Robert Simmons made pictures in Photoshop, and you believe that it's true. Like, I don't
No,
have
no,
to. I don't have to believe in your delusion.
Robert Simmons. Wait a minute, hold on. So making a composite.
I don't have to
picture
believe your delusion.
Making a composite picture means all the pictures are fake when you put them together.
Hey, I can take a whole bunch of different pictures and put them into whatever shape I want, bro.
Is a composite image fake then?
It's not a accurate depiction.
Not an actual picture.
A composite image is not good enough, right? That means anything you take with your cell phone is
because
basically.
You know what? I can go high enough up and take pictures of my whole entire county that I live in, and I can wrap it around a ball. Does that make the county that I live in a ball?
Could also
They're real
put it in
pictures.
a funhouse mirror game, you know? I mean, is that accurate?
Would it match reality? No.
Yeah.
If you took a picture,
it would be actual pictures of reality, right?
No, it wouldn't match reality though. Because if you took a picture of your neighborhood and you wrapped it around a ball, then it wouldn't match reality at all, would it?
Yeah, it would.
No, it wouldn't.
So you're telling me that images of my county that I live in are inaccurate?
If you wrapped it around a ball, just your county.
Okay, cool. So then we can say Robert Simmons making composite image of high altitude images and wrapping around.
NASA, stop interrupting, bro. Stop. We're having a good convo before you came in.
That's because I don't stand to be interrupted, just like you don't expect to be interrupted. But
you're interrupting.
Napalm's responding to Karl.
Can be interrupted.
Just let him go, dude. Stop. Paige.
Apparently, I can be interrupted.
Let Napalm respond to Karl.
Yeah.
And then you can go next.
That's double standard, right?
So Karl, when Robert Simmons made the claim that he took high altitude images and wrapped them around the ball, you would say that would be an inaccurate depiction of reality, right?
You talking about the whole Earth?
I'm talking about. Can you just answer a fucking question, bro? Robert Simmons, you know who that is?
How big a ball? Neighborhood. You're talking about your neighborhood. Hold on, wait. You're talking about your neighborhood.
About the neighborhood, or was it about Robert Simmons, or do you want to deflect from my actual question because it destroys what your claim is?
No, it doesn't. It just shows your ignorance. And how big a ball will you wrap your neighborhood around?
No one's gonna get anywhere like this, by the way.
How big a ball are you gonna wrap your neighborhood on?
Let's say it's 3,959 miles in circumference.
Fine, then you would have an accurate depiction of your neighborhood.
Okay, sure.
Because you can measure that radius.
Cool.
No, you have
so Karl, do you agree with SE, or I'm sorry, with NASA Shill, that you can take images and distort them, and that still is reality?
You don't distort them when you wrap them around the ball.
No.
Okay, so a flat image wrapped, so a flat thing wrapped around a round thing creates no distortion?
If you have a lot of, depends how small the pictures are.
How big were the pictures that Robert Simmons was using?
I don't know. This is your claim, not mine. See, the thing about it is
Robert Simmons is just my claim that he exists and that he did this?
The very first blue marble was not computer animated at all. It was a real picture taken real film by real people.
It was a real picture of a painting. I would agree with that.
It was a real picture of the Earth taken halfway to the moon.
Incorrect. It's a real picture of a painting. Prove me wrong. That's my claim.
Yeah, well, I know it's your claim, but we have the negatives. And,
when you take a picture with a camera of a painting, do you get negatives?
Painting.
Do you get negatives?
It's a painting now. Got it. I love it.
Do you get negatives?
Wow.
When I take a 35 millimeter camera and I take a picture of a painting, do I get negatives?
What are you smoking to get this much denial? I mean,
you can't even answer a simple question. I mean, I've developed film. I've made pictures. I've
To me,
done
this
it for a
dumb.
very long time, and I know what negatives are, and I'm very experienced with that. And if I take a picture of a painting, would I get a negative?
Oh, it's a painting now. How do you know it's a painting?
How do you know
You're
it's
just saying.
not?
You're just postulating. Right. How do you know it's not? Exactly. Typical flat
Exactly.
earther.
So your claim has no more valid than mine
What?
because there's
What about
negatives.
this? It could be this. It could be this. It could be something fake.
It could be that some man flew all the way there, but nobody's done it since.
Oh yeah, we're gonna do it again. We're gonna do it again here in about 2 weeks. It appears.
Yeah, I was told we were going to do it again like 3 years ago, and I was told
Well,
we were going to do it again
it's a matter of
15 years
money.
ago,
Yeah,
and I
it's a
told
matter
we
of
were going
money.
to do it again 25 years ago.
Yeah, it was a matter of money. It was a matter of money.
Oh
And
yeah.
It was a matter
Sure.
of money and will. And it actually looks like it might happen here in 2 weeks.
Oh, in 2 weeks? Yeah.
2
You
weeks.
going? You flying up there, NASA Shill?
I wish I would.
You taking your 35 millimeter camera? You going to get some negatives of that image?
I would do it in a heartbeat. Actually, they're not going to take negatives this time. They'll probably take,
Yeah, exactly. Well,
not-
you
this is-
and Karl's spot
since-
just got blown up because you have to admit that you can't actually replicate what you claim Earth is in science. So you just take it as speculation.
Goddamn, I was talking. He interrupted me.
Yeah,
I will not.
I'm just going to walk away from this
standard.
conversation because
Yeah,
you're
of
acting
course.
like a
Run away.
5-year-old,
Run away.
dude.
Run away. Bye.
Yeah, don't argue with idiots because they'll bring you down to their level.
Exactly.
And
That's
they'll
why
beat you
that's
with
why-
experience.
I know
Yeah.
exactly. You're doing a good
Yep.
job of it. You're doing
Yep.
a really good job of showing your ignorance.
It's not my fault you lack the comprehension to understand the argument.
I lack the comprehension.
But you can just call names. You
No,
probably
'cause
don't
you
even
are.
know what that statement means. You probably lack the intelligence to understand that statement. But
Right,
that's cool, bro.
right.
Go ahead,
Right.
go ahead and act like a 5-year-old with somebody
What's
else.
your background
I'll
in
get back
science?
to work. Have
What's your
fun.
background in science? What were you working? A janitor or something? Like, that appears to be the. You're working on Sunday.
You think I'm a janitor? I'm
No,
more
no.
highly credentialed than you are, dude. By the way.
I'm more highly credentialed
you
than
doubt so?
everyone in this room. I'm the smartest dude in the room, and I am a
Right.
janitor. So.
I know. I got it. You know, I saw. I know. I saw that documentary.
You didn't watch Goodwill? That was a documentary.
Yeah,
yes.
I have credentialing that's almost as high as medical doctors, but I'm sure you you know. You're more intelligent than me. I'm sure.
NASA Shill knows everything because he's the smartest. Yeah, he's a scientist.
I
that's
don't
what he
believe.
claimed.
I don't believe
you're not
credentialed
a
in a heartbeat.
scientist. You're
A
a
medic-
pseudoscience.
Where did you get your
You're a
science
clown.
degree
That's-
from, NASA Shill?
Yeah.
Where'd you get your science degree from? And what level of science?
It's a master's degree. I'm not going to tell you where.
Master's in what?
Chemistry.
You have a master's in chemistry?
Yep.
Does that make you qualified to talk about astrophysics?
In a manner of speaking, yeah. I mean, it makes me
Cool.
shows me that I have it.
No,
It shows me I know way more about science than your average.
We've quizzed you on
Hey,
science.
here
You
we
don't know
go.
anything.
Look who's talking.
My wife,
the sanitation engineer.
My wife has her bachelor's in chemistry, and she doesn't even know what a covalent bond is. So that really doesn't mean
What?
anything to me.
She has a bachelor's in
I'm gonna start using
chemistry.
that.
Doesn't know what a
Hold on.
covalent
What'd you
bond
say,
is?
Paid? What'd you call me?
A sanitation engineer.
Yeah, I need to start I'm gonna start using that one. All right.
Yeah. I saw Good Will Hunting. That was a very good documentary. I guess all janitors.
I got some questions on SR-71 if you wanna. Napalm, did you want to keep this going for about 4 more hours with Paid? I got some SR-71 questions.
It's got a book on it. Yeah.
When you're linking up to refuel them in the air,
Yeah.
What call signs did you use? Like, what did you say to those guys on the?
They usually use the
radio?
Aspen call sign, and the believe it or not, when we did the refueling with the SR, we were pretty much radio silent, as much as we could be.
So no call signs.
They in the peacetime they were called Aspen, and we had differing call signs usually because that's the way they did.
So when you're reconnecting with them, you're that's the call sign you're using, or were you radio silent?
Oh, we were radio silent with them. There actually was we had a communication with them through encrypted channels. It was at the time was classified. I guess it's not anymore. They had some pretty
So
cool
you
equipment.
did have communication with them, or you didn't?
We did, but we weren't talking on the radios, if you will, using call signs.
But there were radio communications between the two of you?
Yes.
The refueling process is like a well choreographed thing. They They do just hand signals and stuff. They don't talk to each other.
Right. Well, in a
It
normal,
was.
yeah,
I was trying to trap. I was trying to trap Paid there. I already knew they were radio silent. I was trying to get him.
yeah, most or less radio silent. We did have like I said, there was this basic. It was a radio signal back and forth that was encrypted. We could tell distance and direction. It was pretty cool. We were the only ones who had it, but that's one of the things that made us unique. There were only certain airplanes that could, certain tankers that were modified to refuel the SR. They were the Q
And
models,
they got rid of the SR-99, right? So that
something like that.
means something like that. Yeah, 99 was the last flight.
Well,
Other places got rid of it a lot sooner, but
I
the
mean,
last possible.
Yeah, NASA. I don't know if they refueled the NASA guys or not. I'm not familiar with that. They probably did because they were so dependent on refueling.
So when was the last time you refueled the SR-71? If it
Um,
wasn't in 99.
it was earlier than that.
Well, when?
Yeah, I'm not gonna tell you. I've already doxed myself enough.
Bro, how old are you? You got to be old. You got to
Already
be
doxed
old,
myself.
dude, because they're not letting the young gun. They're not letting the new guy fucking refuel the SR-71, right?
Actually, the new guys did. No, the refueling part. The younger guys. There were some pretty young guys there flying it. But they took the Q models and re-engined them and named them Ts. Although I guess they don't use the ability anymore to keep the center, keep the body tanks separate from the wing tanks, which was basically what the. So you had the cool part about this is you had a connection they called a single point refueling system, right? That's the connection. That's the name of the connection. So the Q model tankers had two single point refueling connectors.
Did
Now
they
figure
use
that. That's
the point of contact? Was it magnets?
magnet? No, it's a boom.
It wasn't like It didn't like You had to like stick it inside the thing,
Yeah. I
like a
don't
gas,
think it was
like you're
magnet.
at the gas pump with your car. You had to like actually get it in there.
Right, and then it would expand a little bit to hold in there. I don't think there were magnets involved. The boom system is the boomer. That was his system. I don't think there was magnets involved.
I'd like to think there'd be magnets involved in that,
I don't think so.
just to
I don't
give it a
remember.
little clickiness, you know.
It went in, and then there was it would swell up a little bit. Okay, although see, you didn't want it to be fully connected because you wanted to be able to disconnect it if you had to.
Yeah, that's why the magnets would have been perfect,
Yeah.
but which
So
they didn't use. So I mean, I don't know. Did they? I have no idea if they use magnets or not.
I don't think so. I don't think it
I
was
would have put
magnets.
magnets on it. Like I don't know.
Well, then the thing about magnets is then you've got a magnet turn on a big airplane. It probably wouldn't matter, but on a small airplane, having magnets there might mess things up. But it was a pretty cool. Um,
All right. Anyways, back. Let's get back to it. Napalm. 4 more hours with you and Paid. Let's go. Did anyone find any more cool game theory stuff? You guys didn't even look, did you?
game theory for what?
I was just wondering if anyone found any cool game theory stuff. We were going over the angel problem the last couple days. That's pretty neat. And then we did the Monty Hall problem. I don't know which one that
Yeah,
is. The one with three doors and the two goats.
Yeah, then they changed the doors, and you're supposed to change your pick once he shows the doors. It's counterintuitive.
Yeah, I just told everyone to look for more cool stuff. Nobody listens to me though. What else we got? Does anyone have anything or?
That's where it technically ends.
All right, what's
Hold
the
on.
definition of the atmosphere? We want to know. We're trying to figure out when the atmosphere ends. So, what's the definition of the atmosphere?
The envelope of gases surrounding the Earth or another planet.
Okay, so you're saying that that ends at the Kármán line. There's no more layers of gases enveloping Earth after the Kármán line.
But I mean, it's not a hard line.
There are no hard lines with gases. But are you saying at the Kármán line, that's when the atmosphere stops and there are no more layers of gases surrounding the Earth?
I mean, that's where the atmosphere is technically thin enough to where they consider it for the vacuum of space to start. Carbon.
And if it does end, if the atmosphere does end at the Kármán line, why is NASA saying that the moon is in Earth's atmosphere, which is way past the Kármán line? Like that doesn't even go along with what NASA's claiming.
Bro, I explained this to you like a year ago.
No, I just rebut what I just said though.
No, what they're saying is that there's particles of the atmosphere that extend out to the moon.
No, they said the moon is in Earth's atmosphere. That's verbatim from NASA. Not whatever you just said.
First of all, when you start listening to NASA, and second of all, bro, they're just
It's
saying
an
that there's
internal
particles.
critique.
They're
It's an
just saying there's
internal critique.
particles of the atmosphere that reach out to the moon, bro. They're not saying the moon is like in Earth's main atmosphere, bro.
They are literally saying the moon is in Earth's atmosphere.
Okay.
Verbatim.
Well, the Kármán line, it kind of changes depending on who's defining it. So, like the French, they choose 100 kilometers as the standardized boundary. The US often uses 80, but like calculations say between 80 and 120 kilometers. But the concept is like, it's like a range. It's not really like a line.
Yeah, because it's a gradient. You know what I'm saying? So you're trying to put a hard line on something that not that doesn't have a hard line.
Right, but
Yeah,
your
so like at
model
least we
says
took
that it.
on the challenge of like where does atmosphere end and or like where does air end and death vacuum of
Outer
space
space?
start. Yeah. You don't really have the Kármán line because that's a range. So you don't have that.
Right. And you got inner space and outer space now. So this is going to be fun.
I'm saying if
Somebody
y'all
explain
understand that,
the.
if you understand that, then why ask where the atmosphere is? You understand that it's a gradient. Like it doesn't just like there's not one point we can point to and say, okay, here is here, and this is where the atmosphere is. The
So
closest
you're
thing
saying
is
it
the
goes
carbon line.
forever. You're saying it goes forever.
I don't. It doesn't go forever.
Well, where does it end? You just said there's nowhere you can point and say it ends. But now you're saying it doesn't go forever. So which like
I mean, I'm sure it doesn't stretch all the way out of the solar system or some crazy shit, but I mean, you can find somewhere super far away from Earth, and you might find one particle from Earth's atmosphere there. You know what I'm saying? Like it's a
So
gradient, bro.
how do you reconcile gases moving freely but also being stuck to or near
balls
Earth?
stuck to balls.
Gravity.
So it allows it to escape so far that you can't tell where it ends, but it's also stuck.
Yeah, some particles of gas escape. Yes.
Yeah,
Some
I mean
do.
there's
Some
the
are some are stronger.
geocorona, which is like it's like a
Oh,
cloud of hydrogen, which is considered to be a part of Earth's atmosphere. That's why people say that the moon is within Earth's atmosphere.
NASA. That's why NASA says it. NASA specifically. You're going against NASA if you say the atmosphere ends at the Kármán line. I'm just saying.
Yeah, do
no,
you
I
do
ain't
you
saying
feel
that
like the
again.
moon is within Earth's atmosphere?
Technically speaking,
Okay,
they
so
have
then before
particles
when
of
you
the
said the
atmosphere that reach
Kármán
to the
line,
moon.
which is like 80 kilometers to 120 kilometers, to try to like get a point where Earth's atmosphere ends, you're not even close. You're off by like at least 2 miles.
No, I was just using it as that's where they usually say space begins. Is at the carbon line. They consider that now you're in space.
Yeah, the
But the
question was like
atmosphere,
how far does Earth's atmosphere extend? And if you say like 80 to 120 kilometers, the moon is like at least like 10 more miles away from that. Some people say the moon is 238,000 miles away. And if you say like 80 to 120 kilometers, you're off by like at least, let me do it, like 5 miles, at least
oh,
5 miles.
I'm sorry for thinking that
At
Jeremy
least
was
5 miles.
asking me. I should have known that two motherfuckers weren't asking me a good faith question.
No,
No,
it
we
is
I
a
should
are.
have
good
We've
known,
faith
asked
bro.
this.
I
question.
walked into the crowd. It wasn't a good faith question, bro.
It is
We've
a
asked
good
this.
faith question. A good faith question is a question that's aiming to lead towards a conclusion. A bad faith question is a question that forces a non-conclusion.
Yeah, you're asking me a bad faith question because you're trying to catch me in a technicality, bro. I
No,
thought he meant Earth's main
he asked the
atmosphere.
question, where does the atmosphere end? And if you said, well, some people say the geocorona even encompasses the moon, I think you would have said, okay, you agree with NASA's position then. It's not a bad
Pretty
faith
much,
question just because
basically what
like
you're
just
doing.
because you don't know the answer to a question doesn't make it a bad faith question.
Bro, I do know the answer, but pretty much what you're doing is you're saying we're at the beach, and you're saying, "Hey, Carl, what a beach in?" And I point to the parking lot, and you say, "Well, they got some grains of sand, over there at that gas station a mile away from the beach. So is the beach there?" That's pretty much what you're saying, bro.
Hold on. You got a positive claim that there's a magic barrier somewhere, and then somebody asks you how
Whoever that
and
is,
what
you're
it's made out
roboting.
of and where it's at, and you're like, I don't know, it's up there somewhere.
You're robot. I didn't hear what you
But
said.
but
He
your
wasn't even
position is a
roboting at that.
positive
That's just
claim,
how he sounds.
though.
You're a robot.
I mean, it would only be bad faith if you were insisting that there has to be a sharp boundary and then using like the lack of a sharp boundary to disprove the concept of an atmosphere. But
No,
you're
you're
asking for a boundary in every context that's reasonable.
no, you're asking me where the atmosphere is, and colloquially, right? When we talk about the Karman line, that's technically where they say space begins. Okay, and then you say, well,
No,
Carl, NASA
technically,
said that the moon is in the atmosphere. Yeah, okay, they got particles of the atmosphere that reach out to the moon. Okay, you got it.
you said
Congratulations.
technically the Karman line, but no, technically, you're not going to get more technical than NASA, right? And they say technically the atmosphere, encompasses the moon. So
Right. Why do they say that? Because they have particles of the atmosphere that reach out to the moon.
because the atmosphere goes as far out as the moon, yeah, not the Karman line.
Oh, but you can say the same thing about the beach. Oh, they got a grain of
We're
sand
not
over
talking about
here.
a beach, dude. We're just
Yeah,
saying
I
But
by
could
it's
the
the
I
beach.
same
could easily
principle, bro.
invalidate the beach analogy if you want. So like the beach is a human defined category based on like loose criteria. So you have like the slope, the shorelines, and the usage of it. So like that's dependent on context. The atmosphere is vague due to what's called physical continuity. So it's a real physical system governed by gas laws and allegedly gravity, which it has measurable properties. That like those change continuously and predictably. There's no sharp boundary. The beach has a sharp boundary.
Does it?
Yes.
Okay, so if I find so where does the beach end?
Probably at the boardwalk.
Okay, what if they got sand across from the boardwalk? Would you say the beach is over there, even though there's sand from the beach over there?
Okay,
No.
so that's like
So that's the
asking if I
same
go to
thing.
the park and my child plays in the sandbox, and then we go to the beach and there's sand in the parking lot, and my child sits in it. Now my child is in the sandbox.
That's what I'm saying. That's where you're saying when you say the moon is in the Earth's atmosphere.
No, it would be ridiculous to go to a parking lot with sand in it after I was in the sandbox with constraints, and then I'm in the parking lot with sand in it, and my child sits in it, and now he's still in the sandbox. No, there's physical constraints.
Oh, you're talking about a sandbox. I'm talking about the beach. The beach doesn't have a constraint.
Yes, it does.
Oh, it doesn't.
Yeah, there's usually a boardwalk and then a parking
Did,
lot.
did, did, did beaches exist before boardwalks and parking lots?
Yeah.
Okay, so before the boardwalk and parking lot was there, let's say you found some sand, you know, far away from that. Would you say, "Oh, there's the beach over here"? The beach extends this far because you got a little sand from the beach over there. No, that's what I'm saying. That's the same thing you're telling me when you
Wait,
say
that's
the moon is in Earth's
that's his
atmosphere.
argument. You're getting lost, bro. That's what he's saying. It's physically constrained. You're saying it's not.
No, the beach isn't physically constrained. What are you talking about? The beach isn't physically constrained.
He's saying there's a hard line where we say the beach ends, and you're trying to convince him that because there's sand somewhere. Like you're not following.
No, I
Yeah,
am
like
following. So
this is actually kind of weird that we're taking it to the beach, but I'm trying to invalidate how this like isn't a good analogy. So like a beach has sand, and then at the end of the sand sometimes there's gravel and dirt, and then sometimes there's grass. If this grass is a mile away from the sand and the water, and I'm sitting in the grass, and there's no more sand past the grass, the beach has definitely ended.
okay, well, if you find like 2 grains of sand in the grass, you want to say you're at the beach, right? So that's what I'm saying about. I'm just using it's a loose analogy,
That
bro. That I'm using.
proves my point.
Okay, well, I'm using it as a loose analogy, bro, because he's saying that the moon is in Earth's atmosphere because you have particles of the atmosphere by the moon. They scatter out that far,
Oh,
but it's not the
NASA is
main
saying
atmosphere.
the moon is in Earth, not me. NASA is saying it.
Yeah, but I'm telling you the reason why they say that is because you have particles of the atmosphere by the moon.
Okay, that's fine. So when you said at atmosphere ends at the Kármán line, clearly that's not correct because NASA's saying it goes out to the moon.
Okay. Well, if you consider a couple of particles of the atmosphere being out by the moon, the Earth's
Not
atmosphere
me,
is fine.
NASA. NASA does, not me. NASA.
Well, okay, well, fine then, NASA. There you go, NASA. Let's appeal to authority now. Let's appeal to NASA.
Well, yeah, I
But
asked in the
that,
heliocentric model, when does the atmosphere stop?
NASA
isn't
is
that
not
exact?
the herald of the. That's the problem. Y'all think NASA is just like the almighty herald of the fucking heliocentric model, and they're not. It existed way before NASA, and it will exist after NASA.
Who better than to say when the atmosphere is than NASA? They're the only ones that's even been there. Who's been to the
Oh,
moon
they're
better
not.
than NASA?
It's yeah. That's weird to say we're appealing to it when literally where you get the carbon line is from NASA.
Oh, it's not. It's other people who have. They have different countries have different places for carbon lines. The other guy just came in here and said that.
Yeah,
You
the
do
Well, if
understand
carbon
that
NASA says,
line.
there's. You do understand that all cosmologists and people who study this shit are not with NASA, right?
so you're saying there's
Okay,
other people
you're
out
just saying a
there.
different. You're just saying a different government space program. The concept
No,
is
I'm
the
talking
same though.
about
That
in America. I'm sorry, I didn't mean to cut you off. Go ahead. I'm sorry.
no. I'm saying you're saying oh other countries do it too. But our point is that you're saying we're appealing to someone when you're the one appealing to other people to tell you where the carbon line is.
No, what I'm saying is there's other cosmologists that are United States citizens that don't work for NASA.
So what?
Just
And they
because that's I'm
doesn't
saying
make sense.
just because NASA says that the moon is in the Earth's atmosphere because we have particles of the atmosphere that reach that far doesn't mean that everybody agrees to that and gotta adhere to Almighty NASA. That's not how that works. They're
Okay, so
being
you can't appeal to
extremely
the
technical.
Okay,
carbon
so
line.
Okay, are you telling me
so wait,
NASA's
we didn't
wrong
land on
when
the
they
moon.
say when NASA says the moon goes out to the atmosphere? You're telling me they're wrong, and these other guys that have never been to the moon, they're right.
I'm saying technically, bro, if you want to say because they have scarce particles of our atmosphere by the moon, if you want to say that that means the moon is in Earth's atmosphere, then you can.
No, I don't want to say it. NASA said it, not me.
Right.
NASA.
If NASA wants to say that, then they can. But I'm saying that's tantamount of me saying, hey, there's sand over here, therefore the beach stretches this far out.
No, it's not. Nothing like that. Nothing like that.
Yeah, it's the exact same thing.
Literally not the exact same thing. If it was the exact
Well,
same
it is.
thing, we'd be talking about space and gas particles, not sand at a beach.
Well, I'm saying particles of sand. The wind blew particles of sand across the street, so the beach is over there now. That's the same thing with the atmosphere. Oh my God, the atmosphere has scarce particles, 2 or 3 particles over here by the moon. Oh my God, it's in Earth's atmosphere.
Wait, hold on. The wind is blowing by the moon?
No, well, solar wind.
Well, I mean, you're saying our atmosphere is particles. That would be gases, like the wind,
Right,
right?
right.
Or near the
Right.
moon, which
Yeah.
means it would be in our atmosphere then.
Wait, what? No, I'm saying that the Earth loses part of its atmosphere, parts of the atmosphere, and some of them stretch out to the moon. A very scarce bit stretches out to the moon. And that's why NASA say, oh, technically the Earth is the moon. I mean, the moon's in the Earth atmosphere, technically.
No, they're not saying there like happens to be a few Earth origin hydrogen particle atoms out there. They're saying there's a continuous gravitationally bound distribution of hydrogen. That's what the geocorona is. That's not saying there's a continuous gradation of sand from the beach to my house just because I have some sand in my shoes and I took off my shoes and I dumped some on my house. There's not a continuous gradation. So no, it's not analogous. Stop bringing up the beach analogy. It's stupid and wrong.
It is because, well, I mean, outside of the beast not having its own gravitational field, of course those particles are going to be around the Earth because the Earth has a gravitational field. The moon's sitting in it, so those scarce particles are going to be sitting in it too. But what I'm saying is, you're talking about very, very few particles. The moon sits
No,
in a
that's
near
you're
perfect
talking
vacuum.
about disconnected material versus continuous like a continuous gradation process. So like if there is a trail of sand that extended out in a circle from the beach to your house, in other words, your house is on the beach, then yeah, your house would be on the beach, but that it's not analogous. There's no gradient tied to the beach. This is a gradient tied via the geocorona.
Okay,
The
so they have a
particles
beach.
originate from Earth's atmosphere and they continuously and uniformly go out. That's why they call it part of the atmosphere. Not because they
Okay,
found some particles out in space, so like, oh, the atmosphere goes out as far. No, it's because there's a continuous chain.
yeah,
And
it's
they're
scared.
held by Earth's gravity, according to your model.
There's a definitive line. If we go to like somewhere like Daytona or something, or Jersey, whatever, there's places where you can definitively say, I'm not on the beach because you're standing on a street.
Right, so within the globe model, the geocorona is like this. It's a high density near Earth. It gradually decreases outwards. There's no gaps, there's just thinning. In the sand example, it's very dense at the beach, and then there's zero stuff in between. There's roads, grass, boardwalks, houses, parking lots, etc. And then suddenly there's some sand in your house because you took off your shoe and sand is in there. The beach doesn't extend to your house just because there's some sand in your house. I'm
All
just
right, but
saying,
do you
throw away
know
the
how
beach example.
little
It's real bad.
we're talking about trace amounts of atmosphere out to the moon, bro. Trace amount atoms. That's what we're talking about,
No,
bro. Yes, we are. All right, fuck it. Oh, I'm not gonna argue this no more.
no, it is a steady, uniform gradation
Bro,
in
it's a
your
trace amount
model.
of atmosphere. Let's look it up, bro. Let's look it up. Is there any other glober in here besides me?
They don't want no part of this, Carl, because
It is a
this shit is
continuous,
crazy.
gravitationally bound distribution of hydrogen.
Let's see.
Yeah, I'm a Glover.
Oh, there we go. Matthew, where's the atmosphere stop? How high?
It's hard to define. It's like saying when does a mountain, when does a hill become a mountain? It's sort of a gradual thing. So it's not. I don't think it's that interesting of a topic.
How,
There you
how
go.
much of
It's
the
a
atmosphere is
gradation.
out to the moon? How much
Matthew doesn't
of
think
the
it's an
atmosphere? No,
interesting topic, and he doesn't know. I think that was his answer.
no. Ask Matthew
Matthew,
how
do you
much
But
think
of
that do you
how
believe
much.
in like the geocorona being like the gradual, slow, gradual, decreasingly outward, and it encompasses the moon?
I don't know. This is the first time I've heard the word geocorona, but it sounds plausible.
How
So
much of the
basically, the
Earth's atmosphere?
geocorona initiated from a guy named Igor Belukin in the Journal of Geophysical Research. He used SOHO spacecraft data, and they found Earth's hydrogen cloud extending to about 630,000 kilometers away, which is obviously far beyond the moon's orbit, which is like 380,000 kilometers. And it's a very diffuse hydrogen envelope. So it's like a very slow, gradual extending from the ball.
Yeah, that sounds reasonable to me. I don't know if I'd call that atmosphere though. It's just like little bits of particles and stuff.
Thank you. Thank you. Oh my God.
Okay, if that's not the atmosphere, then when does it stops before the geo corona or like what?
Yeah, it would stop before that, but I don't know if you could define it. Like, when does how high does a hill have to be before it's a mountain? It's the same kind of question. Like,
Yeah,
well,
it's a
This is
gradation question, but the geocorona is continuous, it's connected, and it's a physically modeled system. So it's not like the beach analogy that Carlito brings up is like, where does the beach end? I mean, if in the parking lot there's some sand, isn't that technically still the beach? It's not as if you found a disconnected part. This would be a connected part of the modeled system.
Yo, listen to this. It says at the moon's distance, there are only about zero point 0.2 hydrogen atoms per cubic centimeter. Do you know? Do you understand that if you went outside across the street from a beach and found 1 grain of sand, that's more than
It's
the
not
atmosphere you
finding
find on
one
the moon.
grain of sand. It would be finding like sand slowly diminishing to no sand, but you've never found the no sand point.
Bro, do you know how much zero point 0.2 hydrogen atom is? 0.2 of an atom per centimeter. You know how little that
It's
is?
not a real thing. It's not even a real thing.
Oh,
That's
now
just
it's not
like
real.
saying that when it's windy and then
Point two of an atom.
some of the sand blows a few miles down the beach, inland from the beach. That look, we found the beach still goes 2 miles away. We're
That's
finding
exactly what
sand
I
from the
said.
No,
beach.
that's the
Oh my
issue.
God,
That
that's exactly what I
analogy
said, bro.
doesn't work because if so like the beach ends, right? And then there's a boardwalk and a parking lot and a road and then your house. If you take off your shoe and dump out some sand in your house, that's not the beach.
You just got dirt on your floor.
You have sand on your floor. This isn't analogous because this is a continuous, connected, slow gradation of hydrogen.
Gradation.
0.2
Yeah,
atoms
that's like a
per
gradient.
centimeter. Zero point 0.2 atom. zero point
Talk to him.
0.2 hydrogen atoms per cubic centimeter, bro. That's what
That
we're talking about.
doesn't.
Right?
Okay, so what?
So you go to
Do you know
the
how little
Wikipedia
that
for
is?
the geocorona. The geocorona is the luminous part of the outermost region of the Earth's atmosphere, called the exosphere. It is seen primarily via far ultraviolet light from the sun that is scattered from neutral hydrogen. It extends at minimum 15.5 Earth radii and probably up to about 100 Earth radii. For context, the moon is approximately 60 Earth radii away. The geocorona has been studied from outer space by Asteroid satellites and the Galileo spacecraft using its ultraviolet spectrometer during an Earth flyby. It is a gradation. It is not just they found some sand in the parking lot, therefore, like it's a ridiculous. Just throw away the analogy. Stop being stubborn. It's a bad analogy.
Well, I'm telling you, while the atmosphere reaches the moon, it's extremely thin. It's nearly a pure vacuum, and there's zero point 0.2 hydrogen atoms per cubic centimeter.
Okay, so now you've
That's what he
changed
said.
your argument from they found some hydrogen particles, therefore you guys are saying it's the atmosphere. No, it's a gradation. It slowly goes down and down to that point. That's just the furthest they've measured it to be. That doesn't mean they randomly found earth hydrogen particles out there as if someone dragged sand into the parking lot and then was insisting that the beach extends that far. So I'm just asking you to stop being stubborn, throw away the analogy. It's weak. And it's actually
So
like
Okay,
it
does
I'll
it?
really
go.
Hold
obfuscates
on a
any like
second.
productive
So
discussion.
Galley does. So then the uh, the forces that are driving the hydrogen, 600,000 kilometers out of the extending the geocorona that far, the forces that are driving those hydrogen molecules are those are those coming from the Earth, or they are from an external force outside the Earth that are driving that?
I don't know. Why?
So if I was to scoop up some sand and put it in my car and drive it, start driving it away, are you going to say that, oh, look, it's extending the beach? Look how far I just drove this sand. Now
No.
the beach from
I
California
specifically
is in
said
Texas.
no. But that's
Because
not a
the reason why it
uniform
extends so far is
gradation.
because the solar
See, like
wind
the
is
analogy
picking up
doesn't
that
work because
hydrogen
that's
and
not a
carrying it away,
uniform
right?
gradation. So if the beach
Thank you.
uniformly slowly had less sand particles that extended out all the way to everyone's house, and you could trace them back, and you see there's more sand, more sand, more sand, more sand. Now we're at the beach. Then yeah, you could say that the beach does technically extend that far out. But if you picked up some hydrogen particles and you went out a bajillion miles and dropped them off there, no, the atmosphere, that's not proof the atmosphere is extending. And that's the analogy. It's a horrible analogy. And you guys defending it is ridiculous because I'm
Yeah, this is
steelmanning
so
your
bad.
silly
It's like
models.
sandstorms that go
This is
across the
bad.
Middle East carry the sand for like thousands of kilometers, right? The wind picks up the sand and carries that sand for thousands of kilometers, right? So then you would
Jeremy, do
have
you
to
see
say like
like
the
the
Sahara
blatant irony
Desert.
that defending this claim is actually undermining the globe claim? It's ridiculous.
No, it's
It
not.
doesn't undermine the globe claim in any way.
It's a very simple concept, bro. We
No,
telling you,
the
bro,
beach
the
claim.
reason
The beach claim
why.
is ridiculous.
No, it's not. It's very analogous because the reason why, like he just said, the reason why you
Okay,
even
tell
have
me what a
particles out that
gradation
far.
is.
Oh my God, you just gonna just cut me off. But anyway, the reason why you even have particles out that far is because they're being ripped off and pushed out by the solar wind. So if you have a beach and some wind blows and it blows sand across the street, you're not going to say, "Oh, across the street there, that's the beach over there," because the wind is blowing the fucking sand over there.
Okay, how about this? How many atoms per cubic centimeter would roughly would you say the atmosphere ends then? How many atoms got to be there?
Like saying
Me personally, I take the definition of the Karman line, bro. That's what I do.
it's just like saying how many grains of sand you have to stack before a hill becomes a mountain. It's the same kind of stupid question.
Well,
Okay, so do
roughly. I
you
mean, we
say do you say that if I have sand in my shoe and I dump it out in my house, that is part of the beach? Jake and Carlito, is that part of the beach?
No, that's what we're
Okay,
telling
so
you.
if you say no, the geocorona is the luminous part of the outermost region of the Earth's atmosphere. You are undermining the globe claim with your beach analogy.
You're talking about putting sand in your shoe. I'm talking about the wind blowing some sand.
If the wind blew sand uniformly outwards, the beach is extended, yeah. But you were talking about sand in a parking lot and sand away. You could still call it the beach, like as if it was just randomly distributed outside of the confines of the beach. That's not what's going on here.
So when a sandstorm blows the sand across the Sahara, and then that sand starts landing into cities outside the Sahara, right? Regions outside the Sahara. Would you then say that the Sahara is now in that city? That the Sahara Desert came to that city, or the Sahara Desert is in that region that's no longer considered the Sahara Desert?
Is it a continuous density gradient of sand, yes or no? And I can answer the question.
Yeah, bro. It would be.
I mean, it's going to be times where the wind is blowing strong and
Super
times when it's
simple
blowing less
question.
strong, which is the same with the sun,
I'm trying to
right? The
answer
solar
your
wind.
previous question, so I don't know why you're making another claim. Is it a continuous density gradient or not?
Yes.
Yes?
Because you'll have a little sand in the city. You might find 1 grain of sand in the city. Then as you walk towards the Sahara Desert, oh shit, I found 2 grains of sand, 3 grains of sand. Closer you get to the desert, you're gonna find more and more sand until you hit the desert.
Okay, so then the claim that Earth's atmosphere even ends might be ridiculous because you never know if you find like very, very small molecules of Earth's hydrogen atoms. So you
No,
could
you're
never
taking
claim that Earth's atmosphere ends then. If that's your
no, you're
metric,
That's not my metric. You're taking something science is saying
Then
and you're
your
trying to twist it
analogy
to make.
fails. How do you not see how
No, listen,
stupid
bro.
this is?
Because you are trying to take something science says and you're trying to twist it, right? You're trying to twist it into something else. And I'm
How
telling
have I
you,
twisted anything?
when they say that that the moon is in the Earth's atmosphere, they're saying that there's particles of the atmosphere that stretch out to the moon. You're
Via
taking
a
that.
continuous density gradient, and you tried to use something that was split off, like taking
Okay.
sand from a beach and dumping
Good,
them out in the
good.
parking lot and saying that's similar. It's not similar. It's a continuous
Then
gradient.
we'll have our dinner.
Forget about it. You're
Eat in your
purposely
hot
not
mic.
trying to get it. That's what you're
No,
doing.
your analogy sucks, and you're just stubbornly sticking to it as if it's good. And I could answer Jake's question if he answers my question. If it's a continuous density gradient, then yeah, it would still be a part of the desert.
Bro, my analogy's sick, bro. It's one of the sickest analogies
Your
ever.
analogy is horrible.
But God has somehow forgotten.
Eat it in your hot mic, brother.
Well, sorry, guys.
Super sick analogy, bro.
Yeah, you're just being stubborn. Your analogy is really bad, and it obfuscates the actual conversation.
Bro, we're talking about point 0.2 atoms. Point 0.2 of an atom per cubic centimeter, bro. That is less than 1 grain of fuck. That's less than a grain of sand.
Is it a continuous density gradient from the Earth? Yes or no?
Define gradient.
God.
Define gradient.
Slowly
You see-
dropping from one thing to another, or slowly
Slowly.
increasing from one thing to. Don't interrupt me while you ask me to do a thing, Zanick. You just got here. Chill out.
Go ahead.
I got the definition here.
He
Do you
wasn't
need
done.
the definition? You want a
Hold on.
definition?
He wasn't. No, I want to know his because he said something slowly.
Wait, are you saying there's different definitions? What gives the words
Oh,
meaning?
yes, there are. There's different rates. What is the rate of this decay of the atmospheric density? Do you know it?
Okay, that is the
Yeah, 70
definition.
atoms per centimeter cubed.
How many atoms per centimeter cubed?
Zanick, wait, do you know the topic on the table? The topic is it analogous to say that just because there's hydrogen atoms near the moon, that's equivalent to if I have sand in my shoe and I dump it out of my home, it's like saying, oh, well, the beach extends to my home because there's sand in my home. No, it's not analogous because that's not a continuous density gradient. But if the beach slowly dropped down and down and down with sand and then less and then less and less, then yeah, it would still be the beach until there's no sand. So that's why it's
No,
not
that's the
analogous.
analogy you made. That's not the analogy we made. That's the analogy you made.
You're making two distinct analogies, which both have a lot of truth in them. For example, the reason that some of these hydrogen atoms or helium atoms would then maybe get us out as far as the moon and not and remain in orbit is because maybe they had a collision. So maybe it's analogous to the guy with the sand in his shoe walking 1,000 miles and dumping the sand out. Is that part of the atmosphere? Well, yeah. Why? How did he get there? Well, the guy drove his car and took a plane and got out to his house and dumped
Via
his shoe out.
continuous gradient,
So
not a
it's not.
random
So it's not. So
distribution
it's,
of
hold on.
atoms
This
near the
is where
moon.
you're incorrect. It's not a continuous gradient, meaning in a equal rate of decay. That's what you're implying.
The
I don't think anyone's
geocorona
ever,
is a continuous gradation. A tenuous spreading cloud of neutral hydrogen atoms forms the outermost layer of Earth's atmosphere, representing the transition from the atmosphere to outer space. Source nrl.navy.mil. It is a continuous density gradient. The hydrogen density decreases with distance, starting from the exobase, roughly 600 to 10,000 kilometers, and extending outward. Density drops from 70 atoms per centimeter cubed at 60,000 kilometers above the surface to approximately 0.2 atoms per centimeter cubed around the moon. The geocorona stretches to at least 100,000 kilometers, or up to 630,000 kilometers, roughly 100 Earth radii, which is beyond the orbit of the moon. It is a continuous density gradient.
Does it ever just stop? Is there
You have a rebuttal?
Does it? Yeah. Does it ever just stop? You're saying it's continuous. It means it goes all the way out to
Okay, so
Mars?
how is the beach analogous, Zanick? Because that's the topic on the table.
Because that
Do you think
is
the beach is
well,
analogous?
because the
Yes or no?
forces are known for what happens with sand, and or there's distribution statistically what happens with sand at the beach rolling out to the inner cities. But we're talking about some statistical analysis of these atoms that will statistically spread out exponentially, and that rate of exponential decay is not consistent. It's not a constant. It's variable.
It would only be analogous if beaches
Even though it's
never end.
exponential, hold on. Even though it's exponential, it doesn't have a predictable or constant rate of decay. It
Yes,
varies.
it does.
No, it doesn't actually.
I read the
You
predictable
misinterpret what you
constant
read.
rate of
Not
decay.
constant. It's not a constant rate.
I could
Yes,
see why
it
the
is.
logic could be non sequitur too from what they're saying, because if it is the case that I have sand in my shoes, therefore I went to the beach, I could see why the analogy, why their theory would fall apart, because it seems non sequitur. Like they're saying a thing that does, and then they're concluding with something that doesn't follow, which is a definition of non sequitur.
Yeah, there's a lot. There's a lot of areas. There's a lot of areas of space that have zero particles. The rating is just it's not an even distribution. And it's not an even decay. There's sometimes one atom per cubic meter. Sometimes even worse than that. One atom per multiple cubic meters. There can be in the same area or distance from the Earth, because it's more
All
of a
right, Zach,
statistical
I'll walk
analysis.
you through an analogy. You tell me when the beach ends, right? You're at the beach, hanging out with the kids, right? You're on the beach, near the shore, right? You go to the boardwalk. Did the beach end?
The beach never ends.
All right, there you go.
You're done.
You're done.
Because it always make its way farther across the boardwalk. Wind, just like the interactions between
Well, I could
atoms.
keep going further and further, right? So, like,
Yeah,
you're in
you
the
can't.
parking lot. Did the beach end?
So it's a silly bit, because we're with the definition, and have one sand catches the wind and it flows out to Kansas. Is that still the beach? Well, yeah, by definition, it's
Wait,
still
are you
part of the
Zanick? Are you saying life's a beach?
life's a beach. Then you die.
So you would agree with what NASA was saying then, that the moon is in the atmosphere because there's specks of atmosphere out there?
Yeah, technically yes.
Okay,
Well, I
so
mean, by
you're not even on Carlito's side then.
Yes, he is.
No, not.
Wait, what? You've just been fighting the whole time that because there's a couple specks that's not the atmosphere.
No, I haven't.
Yeah,
Yes.
that's why I said
What?
your analogy undermines the globe model. Anchovy's been tracking.
You
Oh
don't
my
understand what I've
gosh.
been saying. Jeremy asked me, listen, you said that
Oh
the
my
moon was in Earth.
gosh.
You said the moon was in Earth's atmosphere. I said saying the moon is in Earth's atmosphere. It's like the only reason they say that because you have trace amount of particles that reach out that far. It's like blowing sand off the beach with some wind and saying, "Hey, it's some sand over here. We're still on the beach." That's
Yeah,
why NASA says that shit.
All right, let me see if you're tracking. What was my rebuttal to that analogy?
Fuck, I don't even remember, bro. It's been so long. You said some stupid shit.
I
Bro,
repeated it several
This is
times.
like a gotcha conversation, right? It's all like, oh, I gotcha.
This kind of
Hey,
is
it
the
was like
issue.
a
So,
dumb
like,
thing.
you say that I'm engaging in bad faith, but you don't even know what my rebuttal was to your beach analogy. So I can repeat it for you, and you can tell me if it fails. Okay?
After you do that, can you tell us what your real point is here? I mean, I'm really curious as to what the real true point is. Like, what are you objecting to, or what are you actually saying? After you
I mean,
answer that.
Jeremy was asking where the atmosphere ends, and I brought up the geocorona, which is the luminous part of the outermost region of Earth's atmosphere because of the continuous gradient. And I would say that according to that model, the atmosphere extends past the moon.
And
No,
it
that's not what happened.
exposes the kettle logic of the globe.
No, that's not what happened. Jeremy asked where the atmosphere is, and I said the Kármán line, and then he said, "Well, NASA says that the moon is in the Earth's atmosphere," and I said the only reason NASA says that is because they have particles that stretch that far. And I said, like a beach, if you blew wind, you know what I'm saying, cross the street, just because you find a grain of sand, would you say you're still at the beach?
Yeah, but you were
I said,
making
that's
the
what
point. You were making the point to disagree with NASA, right? And that your line is the carbon line, and NASA's. You even brought up all these points about NASA's not the only country doing this, and it's
Yeah,
like,
I
come on,
said
bro,
they're a
you're
And then
I said
backtracking.
Zanick
I said
directly
technically.
refuted your
No,
analogy
no,
because he said the beach never ends, not at the
no.
boardwalk.
Yeah,
I said
I'll show you
NASA.
why. I'm just gonna show you why one more time why the analogy fails. So to say there happens to be a few Earth origin atoms out there, is like saying, well, there's a couple grains of sand in the parking lot. You're describing disconnected material. There's no like continuous transport process that links the parking lot to the beach. There's no
Yeah,
gradient tied to a single governing system. So when
there
you're talking about
obviously
the
is.
geocorona, it's particles that originate from Earth's atmosphere. They're held by Earth's gravity, and their distribution is shaped by radiation pressure, escape velocity, solar interaction. There's a causal chain.
You
With the
missed one.
parking lot, there's no causal chain.
There is.
Right,
You left
because I said
out.
that the beast doesn't have a fucking gravitational field.
So
Right?
now Zanick says there is, and you said right. So are you guys agreeing or disagreeing?
We're agreeing that
That
those
says
you
there is
left
word.
out something critical there. Yes, there are some causal instruments, and yes, there could be thousands and thousands and millions of people all walking in the parking lot distributing sand granules in that parking lot. Just like they're not just solar effects and other types of escape velocities. What are the escape velocities caused by? These collisions. So these collisions are very analogous to someone just having sand in his shoe and walking out in the parking lot and dropping one. So that's the equivalence of that particular
Okay,
class.
when does that stop? When
Great,
does that
great.
stop then?
So
Never
So
stop.
the
that
geo,
by
As long as,
that,
as long as
okay, then by that analogy, if that is the case, then Earth's atmosphere extends to every part of the galaxy, to the
Yeah,
whole universe.
we already know Zanick agrees. He said that the whole world's a beach, right? He doesn't. Carlito's the one gaslighting us that he hasn't been taking the opposite position this whole time.
But
No, I
Carlito's
said
not
Zanick
sure if
technically,
the
is
bro.
top of
correct,
Mount
Zanick is
No,
Everest
bro.
correct.
is the crust of the Earth, or if the
No.
base of Mount Everest is the crust of the Earth. I had to
I
explain
said
that to him.
technically. I said y'all are trying to kill me on the technicality. Y'all tried to bite my head off because I said the Kármán line and said, well, the moon's in the
No, it's
atmosphere.
because your
I
stupid
said that's a
sand analogy is why
technicality,
like
bro.
nobody wants to listen. It's like the geocorona is a high density near Earth. It gradually decreases outwards. There's no gaps, just thinning. Your sand example, it's dense at the beach. There's stuff in between. Boardwalk, other thing, road, grass. Then suddenly you find some sand again at your house, and you were trying to make it analogous by saying, "Oh, they just found some of this out there," so that doesn't mean it's the atmosphere, but it's gradually decreasing outward. Now, here's the big issue. It's a categorical issue. So atmosphere can be defined physically as gas bound to the earth following measurable laws. Beach is a category based on environment and processes like wave sediment transport. It's not just defined by presence of sand. So that's the haymaker. Your analogy sucks. Please don't use it again. It wastes a lot of people's time.
No, my analogy was sick, bro. And I was talking about the wind. I don't
No,
know
you're
why you
done.
keep bringing this other shit up. I was talking about the wind. Wind blows sand on the beach. You can find any beach in America. And I guarantee you,
Hey,
if you,
Carl, is it
if I want to
possible
rate
for
it,
you to be wrong? Carl, is it
yeah,
possible? Yeah. Okay.
this is
Then why aren't you accepting that possibility right now?
bro. Is it possible for you not to cut me the fuck off? Is that possible? And can you accept that possibility?
Yeah, so extending the
Yep. Yep.
atmosphere
I just
outwards
did it.
follows its physical definition. Extending the beach outwards violates its definition.
Listen, I wasn't saying it was a one-to-one analogy. We were talking. You know what? Fuck it. I can see. You know what? Fuck it.
Nice. We can get rid of this
Nice.
analogy.
Good
It's great.
job.
It was a horrible analogy.
It was a sick analogy, but I don't
You're
want to argue about it
stubborn
anymore.
and you're conceited. You're not conceding.
Bro, it was a sick analogy. Probably one of the sickest analogies brought up in this Discord ever. Okay, and just because you don't understand it, ain't my fault.
LeBron
What's
debates,
the
man.
standard? What's the standard for sickness here?
It was super sick, bro. Super sick. That's why I said the question was bad faith because you asked me where the
You
atmosphere
mean like
is.
sick in the sense like it's like dying, going away, not very good, not doing well, right?
No, I mean sick.
Yeah, yeah.
Sick is
Like
sick.
when someone is at the hospital and they're super sick, like they're dying or going, that would be like
No, I'm
what
not
your
about to argue.
analogy.
No, we're not about to argue about sick
That
and
was
its
part of the
meaning and
Torah.
plain. We're not about to do it. I
We're
don't
not
understand.
arguing. We're just
I
being
mean,
funny.
I
it's
mean,
just
like,
weird
motherfucker.
because if you agreed with NASA from the beginning, this whole conversation wouldn't have happened.
No,
Yep.
because no. No, I said
Yeah.
NASA says that based off of technicality, bro. That's what I said. You guys don't follow my
So
arguments, bro.
so is it
No, your
true or
analogy
not?
undermines NASA's claim. That's the problem. I just want you to be
No, I
consistent.
didn't. I said if you want to say that because a particle of the Earth's atmosphere is out there by the moon, if you want to say that's the moon there, I
Wait,
mean the atmosphere stretches out that far, you
Yeah, no
can.
one said that.
I
phrasing
said
it
me
that way
personally.
is bad faith though. Like if you agree with NASA, you don't have to make these comments as if you want to say it that way or NASA can say it that way. It's like, do you say it that way?
No, that's why I was getting to next. For
Yeah, no
me,
one said it that
Okay.
way. I said it was a continuous gradation.
Karman line. I use the Karman line. Now, just because NASA and Zanick and other lot of science people like to say, "Oh, well, we found point 0.2 hydrogen atom here, so here's the Earth's atmosphere." Okay, fine, you can
Well,
say that.
That's not what
we're
they're saying.
Well,
we're
you're
not.
the cause. You're the cause of flat earthers then, because what flat earthers are looking for is the real globe. They're looking for the real one. You know what I mean? But if everyone has a different idea of it, then it's like, what is it? Is it even like we need the real one, dude? Could you get the real one for us?
There's no different idea.
No, nobody's
What are you
asking
talking about?
who. Nobody's asking who can say what. We're asking you if it's true.
It's true that particles of the atmosphere extend out to the moon. Now, if you want to call that the Earth's atmosphere and say the moon's in the Earth's atmosphere for that, then fine, go ahead. That's on you.
Is a continuous gradient of gases getting less dense considered atmosphere by definition?
Yes.
Okay, so you consider it Earth's atmosphere. You're done.
Whatever, dude. Like I said, it's a bad faith argument in my opinion.
It's not bad faith.
Hold
Actually,
on, can you
you're
define
the
that?
bad faith element because you're the one forcing a non-conclusion. I just asked you if a continuous gradation of gases getting less dense is considered atmosphere. The geocorona is a continuous gradation of gas getting less dense. So I asked if those are the same thing. You agreed. So you agree that the geocorona is part of the atmosphere. You're done. And then if you say you're bad faith, you're forcing a
Technically
non-conclusion,
speaking,
which, like, ironically makes you bad faith.
not really, because you're talking about technicality, which was my point in the first place.
No, not
You're
technicality, just literal definitions of words that you agree to. You're just
And
being obstinate and disagreeing for the sake of disagreeing, not because you actually believe what you're saying. Because what you're specifically saying agrees with what I'm saying. But you're saying no, but like you agreed to it.
No, I'm saying that
See?
by the moon, you have point 0.2 atoms per cubic centimeter hydrogen. All right. Now, if you want to say that just because that presence alone is enough to say that the moon is in the Earth's atmosphere, you can. By definition, you
yeah, but
can.
so your conclusion is because you already told us it's true. Your conclusion is they say that because it's true. It's just such a weird like. What was the point of the whole conversation then?
No, because
Let me
they
try
don't.
to ask
You know
Anchovy.
what? Fuck
Anchovy.
it.
When I
Fuck it.
asked Anchovy, when I asked Carlito, is a continuous lower density of gases in a gradient form, is that considered atmosphere? Did he say yes?
I don't think he's said anything this whole time.
He said yes to that anyway.
Here's the. By the way,
And then I
here's
asked
something
if
that's.
the geocorona is a continuous lower density gradation of gases. And he said yes. So therefore, the geocorona is atmosphere. Simple.
Depends on the context, right? If you look at the definition, like if you ask an AI, right, it would say there isn't a single sharp agreed upon edge to Earth's atmosphere. It gradually thins out into space. But scientists use a few standard reference points depending on context, right? One of which is the Kármán line used, above this, air is too thin for traditional aircraft to be able to have flight, right? Then they have, the menopause, the thermosphere, exosphere, etc. And then you can go to the geocorona, which is essentially the outermost whisper of Earth's atmosphere, far beyond the exosphere,
Let's
right?
go.
If you're using those words like that, though, how do we know what you mean? Like you're saying there. So are you saying the atmosphere is not an actual thing that you don't even know, or it's just a concept? Because the way you're using it is in the universal concept idea of it, rather than talking about it like it is a particular, because it is a particular according to you. It's a specific amount of gases. So for you to say there is no line you can draw where that is, that means it's not physical.
It depends on the context, though, right? Like if we talk about breathable atmosphere, then we're talking about altitudes at which humans can survive.
All right, Jake, can I ask you two quick questions and like just try to answer yes or no? Like so the atmosphere, right? Do we define that as a continuous gradient of gases getting lower in density?
I don't think that the gradient is part of the definition of an atmosphere. I don't think
Okay,
that's a
how would,
required
if it's
definition
not
in
a
atmosphere.
gradient, how would you
That's
define
not
it?
a full. That wouldn't be a full definition because we have gradients in places that aren't the atmosphere.
So Earth's atmosphere, do you guys define it as a continuous gradient of gases becoming lower in density as you go further away?
Yeah, I'm fine with the definition. I don't know about
Okay,
Jake.
Jake, are you fine with that definition?
I mean, at the most basic sense, atmosphere is just the layer of gases surrounding a planet, right? Now, because of gravity, obviously,
I want to
hold on
ask
a
two
second.
questions.
Because
I
of
guess we're gonna get into the
because
weeds.
because of gravity, it's going to be there's going to be a gradient there, right? But in its simplest form, it just means the layer of gases surrounding a planet. Gradient is not part of that definition.
Do you agree
You
that
guys are
Earth's
making this hard.
atmosphere is a continuous gradient of gases becoming less dense the further you go away from Earth? Yes or no?
So theoretically, if you had the technology,
Dude, it's a yes or
if
no,
you had the
please.
if you had the technology to create separations in layers of gas, and it isn't a continuous gradient, you just had gas, perfect vacuum, gas, perfect vacuum, like shells of that. All those
You just
shells
say
would
yes.
still be considered. All those cells would still be considered part of that planet's
Did he
atmosphere.
ask you for
Even though,
Earth's
even though there's
atmosphere?
no even though there's no continuous gradient, that would still be considered an atmosphere. So
So, like, the
this,
definition of bad faith is to try to not allow a conclusion in a conversation. So, I asked you if Earth's atmosphere is a continuous gradient where gases get less dense the further you go away.
I'm
Pinky
going to change my
answered yes.
definition. I'm going to change my definition to no.
no, because there are sections in Earth's atmosphere where you have lower density and higher density in its shells. Because once you start getting into interactions with the solar wind, you get this layering effect where you can have lower density below higher density, right?
Yep. I agree with Jake.
So then
I can
any
give you my
density
definition.
gradient. So then as long as there's a density gradient, you guys are good. Doesn't matter if it's going up or down, whatever. It doesn't matter. That's called Earth's atmosphere, right?
Our definition doesn't have a requirement of a specific gradient. It's just
All right, I'll
a
try
layer
to.
of gases,
I'll
a
try to.
layer of gas.
I'll
I'll
try
tell
to
you my
tell you the
definition.
definition.
It's a layer of gases that surrounds the Earth, held
So
in
do you
place
agree
by
that it's
gravity.
like an envelope, right? A gravitationally bound envelope of gases surrounding the planet,
Yep.
characterized by a continuous decrease in density with altitude?
No.
I wasn't done.
Oh, sorry. I
You don't
already
think
would say
that
no to that
you
part.
don't think that
Sorry.
the
Go ahead. My
atmosphere is
bad.
characterized by a continuous decrease in density of gases?
My
No,
definition
because
is
for
a
example,
layer of gases that surrounds the Earth.
on the surface of the Earth, you could have very hot air very close to the surface, a few feet off the ground, where the density is lower than the gases a few feet above it, right? So you
You
don't
know
have
what?
you don't have a continuous gradient of decreasing density. And when we get higher up and we start interacting with the solar wind, you can get these areas of much lower density that are below higher density.
Just change it to any gradient. These guys are. This is bad faith at this point because you're trying to make the definition so vague that nobody can pinpoint your position.
We gave you the
So
definition. The
Yes,
definition
basically,
is a
that's
layer of
just
gases
bad
surrounding the
faith.
Earth.
That's
We
bad.
already
So,
gave you the
so if you
definition.
Google it, if anyone were to Google it, yes, Earth's atmosphere decreases in density and pressure continuously as you gain altitude. Air pressure drops exponentially with height because gravity pulls most gas molecules down towards the surface, making air thinner higher up. While density and pressure decrease steadily, temperature fluctuations are not continuous. They rise and fall depending on the atmospheric layer. So that is how atmosphere is defined. You could try to change the definition and say words have no meaning. So anyway, we're gonna go
No,
with
I asked
definition because that's the definition.
ChatGPT. Well, hold on, I asked ChatGPT and it gave a different answer.
What did you ask ChatGPT?
What is the atmosphere? It said the atmosphere is a layer of gases that surrounds the Earth held in place by gravity.
Can you ask ChatGPT Does the atmosphere decrease continuously in density, the gases, as you go higher in altitude?
That's not a definition of what the atmosphere is. So if you want to have a different conversation about that, we can.
It's
not a definition.
It's actually
I
an
can ask it. I can
ontological.
ask it if you want, but that's
Are
not.
you
That's
saying
not
the
the.
being
Yeah,
of the
ask if
atmosphere
Earth.
in reality doesn't exist that way?
So the question isn't about in atmosphere or the atmosphere. The question is, do you agree that Earth's atmosphere decreases in gas density as you gain altitude? That's the question. So when you get a definition that has nothing to do with like Earth's like what, okay, so my social atmosphere is just the people I hang out with, so technically you're wrong. It's like a really ridiculous way to not address the argument, and it is bad faith. So if you
No, I
ask
think what you're doing is bad
ChatGPT,
faith.
does Earth's atmosphere decrease the gases? Do they decrease in density as you gain altitude? If it tells you yes, then I can continue my line of questions, but you guys won't say yes. You initially said yes, then you circled back because Jake said no, because you guys don't want to give a concrete definition, because you guys don't want to have a conclusion of the conversation. You're here
I'm
to
sorry, we're not stepping into your little trap, but
Right,
like
Yeah,
this
I'm
is what
trying.
By the
ChatGPT
way,
says
if
the
you
definition is. We can look up in Google and see if Google gives us a different definition. But
yeah,
you're changing the question now because we didn't
let's
give
look
the
up
The
the
answer you
question is
Webster.
the
wanted.
same. The
Let's look up
question
the
is the same.
Webster definition.
Does Earth's atmosphere, as you increase altitude, does the gas decrease in density? That's the question.
Yeah, I asked the question. By the way, I asked that exact question, and the answer was, in general, yes. In general, Earth's atmosphere in density does
Show a
decrease
screenshot of the question you
with
asked,
it,
please.
but in a perfect uniform way at every time. Hold on.
Yeah, could you show the exact question you asked? And also, it better start with what you just started with in the answer, so that way you don't ask it a different loaded question, because I know you asked it a loaded question. Like,
I can't
show
fit it
how the
all in
Earth's
one
atmosphere is
screenshot
in a
here.
perfect continuous gradient. I guarantee
Right,
you asked a loaded
here's the
question.
question that I read it exactly. Okay, does Earth's
Nope, please
atmosphere
show a
decrease
screenshot.
in?
I don't trust you. One time, I was debating you, and I asked if you were using ChatGPT because 30 minutes were wasted looking for the source of your quote. And we said, "Did you just use ChatGPT? Because it kind of gets quotes wrong one time." Like, and you wouldn't admit to it. We couldn't find the source, and you said no over and over again, and we found out you were using ChatGPT. So I'd like to see an exact screenshot of the question you exactly asked.
I think I remember that. Good
Yeah, it was
way to
wasting
pull that
30
back in and
minutes.
just
It
keep
turns
beat him over
out
the head with it every chance you get. That was good.
if we back
Well,
up for a
listen.
little bit, it's just, the whole problem is that different people have different definitions of atmosphere. I don't know why we're arguing so much about it.
Yeah,
That's why he wants to
skip
to
over.
drag us into a definition that he can say that's incoherent.
Well,
Yeah,
debates are typically
Addition,
over
like,
semantics.
No.
I can
I'm
hear you
asking a
guys.
very specific question. I'm asking, does Earth's atmosphere, as you gain in altitude, decrease in density of gas? What definition am I asking for there?
Well,
The
you
answer to
changed your
your
tactic
question is
midway,
it
so
depends
now
on
we're
what
doing something
definition
different.
you're using.
I posted the exact screenshot since you didn't believe me.
Well, they said it's a dynamic system. It could be higher in density at a higher point, but so besides the technicals, the conversation's very simple. Do you agree with NASA that the geocorona goes past the moon? I mean, we don't have to get into the technicals. It's just, do you agree or not?
Yes, the geocorona does go past the moon. The question is, do you want to call that atmosphere or not? Some people yes, some people no.
Oh, so
Well,
Jake, you
is the
did ask it a
geocorona
loaded
part of the
question, and
atmosphere?
this isn't the question you initially asked when you said you asked it. And this isn't the answer you initially got when you said you got it. You asked it a different question, and it actually agrees with me. Yes, Earth's atmosphere doesn't just end at a fixed height. Its density decreases smoothly in a gradient as you go up higher. So when you asked it an honest question,
It says,
it
but not in a
agreed. It
perfectly
says
smooth,
yes.
uniform way.
When you asked it the first dishonest question, it gave you a different answer. You said yes, but not perfectly uniform, etc., etc. So if you want to share the first dishonest question you asked it, you can do that. But this isn't the first thing you asked it because this says yes.
I literally started reading. I said, in general, but not in a continuously, perfectly smooth, uniform way, which is what it said, which is the opposite of what you just said.
Where does it say in general? Is it the first
It's
picture?
not uniform anyway. I mean, I
Yes,
guess
it
if you
says it.
consider
Yes, in
exponentially
general.
uniform.
Yes, in general. Can you not read? Yes, in general.
No, Beast just asked it. Yes, Earth's atmosphere doesn't just end at a fixed height. Its density decreases smoothly in a gradient as you higher. Yeah, you didn't post your prompt. Beast asked a very simple question.
I
Does
did
Earth's
post my
atmosphere decrease?
prompt. My prompt is in gray. It's in the gray box.
Where is it?
I don't see it. Maybe it went into the chat.
Oh, you know what? I posted it in audience text. Hold on.
By the way, some people are saying in chat that this is just like a semantical debate. It doesn't sound like that to me, because if you have I mean, there are semantics in any type of discussion, and when there's a claim by these kind of mainstream perpetrators that there's this globe idea, and they're putting words to it like the atmosphere is a thing that ends at a certain place, and then you have this outer space, and they say astronauts are going to outer space, kind of a thing. That's a definition. They're calling that outer space versus the globe atmosphere. So there are words that are used in these models of what the Earth is. And it is pretty significant when you have the difference between a globe in a vacuum, because if you took a ball and put it in a vacuum, we all know that there's no way you could make like a livable atmosphere right on the outside of that ball in a huge vacuum chamber on Earth. So there's something else claimed to be going on, that this globe thing has this atmosphere that we live in and we breathe air, and it's very, very different than this outer space medium that they claim you have to put spacesuits on and you'll die. You can't be out there without a suit on, and so on. And so there are pretty significant differences of what's being discussed, and then how far that extends out between what the words that are used for the globe's atmosphere that we're living in and on, that we treat as stationary. There's no detection of motion, etc. But somehow when you go up there, all of a sudden you're in this other medium, and so on. So where that defining line is would be a pretty important distinction for that, if someone's going to put that forward. And also, if the whole atmosphere is supposed to be rotating with the globe, then is it also rotating is the gradient rotating hundreds or thousands of miles out there? Is that gradient also rotating and brushing by the moon as it's rotating as well? So you have that factor too.
Well, they're just arguing to argue at this point. They agree. They said they agree with NASA that the geocorona goes past the moon, but then he also said, if you want to call that the atmosphere, but that is the geocorona is the atmosphere. So it's like, how are you saying both at the same time?
Well, here's a good frame of reference. Hold on. Here's a good. Hold on, my turn.
If the answer to the question is
it's my turn.
So if you ask, does Earth's atmosphere decrease continuously in density as you go higher, and the answer is yes, then is the geocorona a continuous decrease in density as you go farther away? Then the answer is the geocorona is Earth's atmosphere.
Okay, this is the point I want to make. Let's say you buy a vacuum chamber off of Amazon, okay? The best one you can get on Amazon. Okay, if you were to go to where the ISS is, which is way closer than the moon, okay? You're going to have the air density there is going to be, it's like 100,000 times less air density than the best vacuum chamber you can buy on Amazon. By the time you get to the moon, it's so thin that asking like all this stuff that you guys are asking is pointless. There's virtually the molecules are so few up there that it's like that's why it's sort of like a gotcha question about trying to define the atmosphere, but it's
that's why it said that depends on the context. That's what the ChatGPT prompted said. It depends on the context that you
Geocorona
use
is
it.
the luminous part of the outermost region of the Earth's atmosphere, called the exosphere. It is seen primarily via ultraviolet light. It's part of the exosphere.
Yeah, what's the density there? The air density.
Non sequitur.
No, it's not. It's just a question. We're just having a normal conversation. I'll look it up. What's the density?
Question is it part of the Earth's atmosphere or not, according to the globe model?
Okay, let's look it up. What's the density?
I got it here. I looked it up. Yes, the geocorona is considered the outermost part of the Earth's atmosphere, specifically within the exosphere, is a faint luminous cloud of hydrogen atoms that extends roughly 630,000 kilometers into space, which is about 50 times Earth's diameter, stretching past the moon's orbit. While nearly a vacuum, it constitutes the atmosphere's final boundary before space. That's because they know it's a particular and they have to make that claim. So the real globe says so.
I mean, like we'll find we can find a different source that will define atmosphere at a different density point and do a cutoff there.
All right, so you guys
The thing is, the globe doesn't have a problem with
Yeah.
this. It's not because everybody understands that making a line isn't. It's just an arbitrary line anyway.
So,
yeah, not
Pinky, are
Wikipedia,
we in
not
Venus?
NASA, so you can't use those sources for arguments then.
Are we in Venus's atmosphere right now, Pinky?
I mean,
Are we?
no, we're not.
No. So where does that one end? Where does
I
that
don't
one
know.
Okay.
I
So
don't
where
know.
does the
There's not like there's not an exact line where it ends.
where does the Earth one end? Well,
I
if we're
don't
not in if we're not in Venus's, then it had to have ended somewhere. So
Yeah.
you don't
So
know?
somewhere between here and Venus, it ended.
Does anyone know? Does NASA know?
That's
No,
a
because it's not
positive
it's
claim. So where is there? They're asking where. You said somewhere in between. Okay, that denotes that there is a place where it's happening.
yeah. Like, where does the thermosphere end?
The
Dude,
geocorona
we can
extends
Google
way past
these.
the moon.
Could it be where the gravity's so weak it no longer holds air molecules?
No, it's not defined as that.
That would play a factor
Explicitly
as
is
well.
not defined as that. There's a bunch of sources in the chat you can read about it.
Are we in
See,
the
my
sun's
understanding
atmosphere?
is that converting the density in the geocorona to core is like 10 to the negative 17. I was under the impression that we don't even have devices that can measure air density, and that those numbers are basically projections based on mathematical models of how like particles behave.
As a flat earther.
Okay,
You
that would be
know,
a flat Earth
well,
claim.
no, I mean,
So
like you
this
can
is
say
from the
that, but we
European Space
have
Agency.
measured density in the atmosphere up to 10 to the negative like 10th at least. I mean, I don't think you guys comprehend how absolute not pressure that is. And that's
I'm gonna
below we
post
hit any
a
sort
quick
of
thing.
dome, right? There's
Yeah,
zero
you guys
pressure
don't
and
understand.
we
It's
haven't even
not an
got to the
argument.
dome yet.
So this is from the European Space Agency. Earth's geocorona from the moon. The Earth and its hydrogen envelope, or geocorona, as seen from the moon. This ultraviolet picture was taken in 1972 with a camera operated by Apollo 16 astronauts on the moon. A recent discovery based on the observations from the ESA/NASA Solar and Heliospheric Observatory (SOHO) shows that the geocorona extends well beyond the orbit of the moon, reaching up to 630,000 kilometers above Earth's surface, or 50 times the diameter of our planet.
I mean, at this point, it just sounds like you're arguing to argue. I'm going to be honest. Like, you either think it's the atmosphere or you don't.
And like I can pick one. Let's say no, it's not the atmosphere.
Okay, the European
Okay, that's
Space
fine.
Agency and NASA disagree with you. Here's a
You're
specific
a flat
article
earther.
from the that's a flat Earth claim. So the European Space Agency says Earth's atmosphere stretches out to the moon and beyond. Here's the article. You can read all about it. It cites NASA. If you disagree with that, that's fine. But that is the case of the current state of the heliocentric model.
I just define atmosphere differently.
I just define you making claims as differently. So right now you're not making claims. Like this doesn't say anything.
Okay. I mean, I can choose whatever boundary for the atmosphere I want, right?
I mean, boundary doesn't even mean boundary. I can just define boundaries whatever I want. So, like, if we just change definitions arbitrarily, then we're not getting anywhere. No one
Well,
means
where is the
anything when they
definition
say
for
anything.
atmosphere that says that it extends beyond the moon?
I don't know, people that study space that you would appeal to.
I mean, would you accept that?
It's an internal critique. Why would you ask what I would accept or not?
Because I don't know. Would you accept it?
What I
Just
accept is
really bad
irrelevant.
faith.
If I'm saying internally in this model, whether or not I believe it's true or not, this is what it says, and you say, it doesn't say that because I define it differently, would you accept my new definition? No, it
No,
doesn't matter what I believe. It's an internal critique.
I mean, it's like what can constitute space. Different countries define it differently. I know we went over that before, but that doesn't mean anything. It's just different countries define the boundary of space differently.
Okay, which countries
Doesn't mean that there's not a
contest the
boundary.
fact that the exosphere is part of Earth's atmosphere? Go.
Sorry, what was that?
Which countries contest the fact that the exosphere is part of Earth's atmosphere? Go ahead.
But I don't know. I don't look to countries. I was using that as an example of two.
You said
Let's say
different
two
countries say
groups.
differently. So
Don't
which one?
interrupt. I said two. Well, I was using it as an example of countries that differ on the what the boundary is between for space, essentially.
So why would you say different countries say differently if you don't even know if different countries say differently?
No, they do for the boundary for space, but not necessarily for the atmosphere. I don't know. Maybe they do, but
Okay, this is about whether or not the exosphere is considered Earth's atmosphere. Kind of why we're talking about that. Kind of just like throwing mud on something and then saying, why is it all muddy? What makes an orange? What, like, why is an orange an orange?
Well, it's this universal talk, you know, they're claiming it, like the atmosphere is like this thing that it's more conceptual. It's not really, you know, scientific or anything like that, that we could go and measure it or anything like that. But then, you know, they want it both ways, that it's made up of all these physical things and we know exactly what it is and all. Like, that's called kettle logic, Pafinky. You need to look that up, dude. Kettle logic.
I'll
I just want to
definitely look that
also
up.
point out that Jake asked his ChatGPT, does Earth's atmosphere decrease in density continuously to where for every millimeter change in increased altitude, the atmosphere becomes less dense? Whereas when Beast asked ChatGPT, does the Earth's atmosphere decrease in density like a gradient as you move higher in altitude? It said yes. When I asked Google the same question, does Earth's atmosphere decrease? Does Earth's atmosphere decrease? I'm going to say decrease continuously as you increase in altitude. It says yes, Earth's atmosphere density and pressure decrease continuously as you gain altitude. So if you ask ChatGPT a loaded question, it's going to give like a loaded question with like nuance added. Does Earth's atmosphere perfectly decrease in density as you go up higher? Yeah, of course it's not going to give you any type of like concrete answer. So like the
Yeah,
Well,
goal
it's
I
going to
got
tell you
three.
that it
You asked
doesn't.
for
and
examples.
add
You asked for
needless
examples, and I have a few here. So
needless
collisional
big
atmosphere.
nuance doesn't help the conversation because we're looking for clarity.
Yeah, but those
Okay.
answers are just in general. They're not in specific. They're not getting into the nitty gritty of it, right? They're in
All right.
specific. There's the general, not specific. That's why
Okay,
if
is
you
the
want a specific
exosphere
answer,
part
you
of
have to
Earth's
ask a
atmosphere
specific
or not?
question.
Yeah, I agree. Okay, so I found some examples. Collisional atmosphere. The definition is the atmosphere is the region where gas behaves as a collisional fluid, whereas molecules frequently collide, and the boundaries of the exobase. So, according to this definition of atmosphere, you would not include the exosphere as part of the atmosphere. Second one is continuum fluid regime, which is an engineering definition, which is used in aerodynamics, CFD flight physics, which says the atmosphere is a region where air can be treated as a continuous fluid using the Navier-Stokes application. And the third is a sensible atmosphere, which is used in weather, aviation, and human relevance. So these are three definitions of atmosphere where they would not include, they're not including the exosphere in it.
Earth's atmosphere, right? Definition of Earth's atmosphere.
Correct. Yeah. So if you ask like a meteorologist that's working, that's gonna they send up stuff on balloons, they don't consider that up there the atmosphere. It's not part of their realm. I would even question whether the exosphere, the density up there, has actually been measured. I think it's something they saw. They saw like the photo that you were talking about, and then they hypothesized about what the presence of what particles would cause that behavior.
It's probably
Okay,
like
so
mathematically inferred,
in
right?
the
There's no direct
collisional
way to. There's no direct mechanism to measure it.
Thanks, Jake. So the collisional atmosphere definition, where does the atmosphere end if it's not past or beyond the exosphere? Because the way that you framed it was that it ends before the exosphere.
Yeah, it says the boundaries of the exobase.
Where's the exobase?
Before the exosphere.
So right before the exosphere?
I don't know. I don't know, to be honest. I chat GPT'd it, obviously.
So we don't even know?
Where does the exobase end? Because I feel like it's just the whole concept of the question is, I feel like it's intended just to be a trap. Like if you ask, if you're talking to somebody and they're like, yeah, I do meteorology. We measure all the way up in the atmosphere. density, we measure temperature, and then you guys come along and you're like, well, technically you don't because you guys don't send balloons up past the moon, right? It's like it's kind of like a dumb argument for a gotcha.
No, the argument was
That's
about
just
whether
your
or not the
opinion.
silly
Though.
sand analogy worked, and then some people agreed, some people didn't.
I think I missed the analogy, so.
And it was like if you find sand in a parking lot near a beach, did the beach continue to the parking lot as if it wasn't a continuous gradient, like the atmosphere wasn't a continuous gradient? But the fluid like collisional atmosphere, they have a specific criterion, which is arbitrary, but it's for their purposes. It's the atmosphere ends where gas particles no longer collide frequently enough to behave as a fluid. So that's just in a very specific, like that's taking it to a very nuanced, specific thing. We're talking about gases slowly decrease. Like you can no longer consider it a fluid at this point. That's 500 kilometers above sea level, which will to 1,000, which will vary with solar activity. Whereas I think a lot of people agree that Earth's atmosphere extends out further than 1,000 kilometers.
Yeah, they're saying
And there's
like
the
you're not getting
aerodynamic, which is the
collisions,
carbon
which
line.
means like if you have an air pressure in which there's not even enough air molecules to create collisions, do you need a container for that? Like it's not even going to be pushing
Yeah, you
against the
need a
container.
container. Yeah, for any kind of molecules to exist, you need containment.
Why?
Why? There's no. This is what
You need
this is
because you
saying.
have
Oh, God.
because you need a universe in order to have things.
So
So
the
there's your
universe is the
container.
container.
Yeah, there you go. So yeah, exactly. So there's no such
You're
thing
talking
as
past each other now.
molecules without
Your
containment.
fence.
I'm talking about gas pressure, obviously.
Yeah.
Like
Let him finish speaking. I mean, Zanick, you said the beach
I'm just
extends
talking about.
forever. So.
No, I mean your defense of so now you admit that there could be we also could agree that we could be in one big solid universe with boundaries, but that's not the reason we have gas pressure.
But you said the beach extends forever, so it would stand to say that the Earth's atmosphere extends forever by that criterion.
If you define it as just particles that came from the Earth, but the atmosphere is
How would
actually
you know
something that shows that it's surrounding the Earth and stays around the Earth. So you have to find out what point these atoms are leaving the Earth, and they wouldn't be considered the atmosphere. Just like
It's
the sand
the
at the
gas.
beach doesn't go past the parking lot.
Gas molecules are the necessary precondition for gas pressure, right? You have to have gas molecules, and you're going
Correct.
to need a universe in order to have gas molecules.
Great. So we have everything that you talk about existing needs to be the prerequisite is having a universe. Okay, we all agree. Everything, no matter what you light, gas pressure, bunny
Yeah, that's your
rabbit,
container.
everything needs a universe.
but now you're
Okay,
avoiding
so
the
you
question,
made it.
Toro,
But point,
because the question
this
is
getting,
if
even
gas
Geo said this wasn't
molecules
being
don't
pedantic,
collide enough
getting more and more pedantic with
to
every
be
type of
considered a
requirement you're
fluid.
making.
No, sorry, Zanick was talking. My bad.
I mean, you got to make your point clear. What are you really trying to ask? And if you're saying we just don't think it can exist because we don't believe this atmosphere has any reason to surround the Earth and have a gradient, which it does, in the gas law and the law of atmospheres describes it almost perfectly. The air has weight. That's it. End of story. Done. Next topic.
Yeah, next topic. And I just want to add to Pinky, the reason why I wouldn't really go with the nuanced definitions of atmosphere is because I could just say my social atmosphere extends I don't know 100 miles from where I live. So therefore, if I define atmosphere as my social atmosphere and all the people that I know, you know what I mean?
It's not the
It's
same
very
thing, though. We're talking
arbitrary.
about physical characteristics. Your social atmosphere isn't a physical characteristic.
Yeah, it's more of a mental problem.
No,
Yeah,
because
these are all
other
dealing with the
atmospheres he brought
gases.
up, the other atmospheres he
Well, let
brought
me
up.
respond to it. I think it's a fair point, but the way I'd respond to it is by saying that the general definition of atmosphere is the layer of gases that surround Earth held in place by gravity. Every definition I gave you is within that context.
Right. And also, what if you start eliminating things like hydrogen or individual atoms? Let's say molecules. So if we say, where do the molecules end?
in our atmosphere? That would probably be a more valid question, and then we might have a more narrowed answer. But it's still not going to be defined at at exactly 123.657 miles. You'll find the last oxygen molecule or nitrogen
Yes, I
molecule.
wasn't even making like a definitional argument. I was just asking the question if Earth's atmospheric density and pressure decrease continuously as you gain altitude. And like the answer should be yes, because like any reasonable person would say yes. And then does the exosphere like behave like this just like the rest of the atmosphere? The answer is yes. So therefore, the exosphere is part of Earth's atmosphere.
I would contend that the exosphere acts like this because I don't think we've actually measured any pressure there.
Nice.
I think it's all a mathematical model. I would say go up as high as we've have actual devices that measure it, and that's probably as far as I'd be willing to make a claim about it.
Based, reasonable take. Thank you.
And Galley, your social sphere extends all the way to Utah, buddy. I just want to put it out
Extends all the
there.
way to Romania, man, and New
Yeah,
Zealand.
I just want from Romania to Utah. I want to put it out to Vegas, the likes.
We
I
got a
took your
Utard
image.
here with us.
I put your image into a reverse image generator, the one of the Earth's corona, and also looked it up with some star charts. Turns out that there is no constellation to match that image, and so therefore your image that you provided is therefore fake and gay. So just throwing it out there.
Did you? Well, I hope we all agree that this gas pressure that we can measure, or that is even defined by what gas pressure is, would you all agree that in order to have gas pressure, either a gas molecule has to bounce off of some container or a sensor, or bounce off another molecule or atom? Would you agree? Would everyone here agree that that's the only way gas pressure can happen is if there's a collision?
Not a collision.
Is there anyone that doesn't agree with that collision theory or idea? Can you have
Not
gas
a collision,
pressure
but a container?
No, I've already talked about the Gaussian collisions being no different from the side of a container from those atoms or molecules hitting each other. There's no difference at all physics-wise. Rate of change in momentum is defined as a force, and that's what happens. This force is over an area. That area of force is a pressure. Now let's go back to the basic question I asked and see if everyone agrees. Because if we don't, then we have a serious problem. Does everyone agree that pressure, gas pressure, is, by definition, a collision between two or more molecules or atoms off either the surface of a container or off of each other?
I'll agree to that.
Anyone? Okay, good.
No,
Anyone
he's
not agree?
he's trying to back you up into well, if you agree with this, then this is happening there.
I'm not.
Yeah.
Galley did it a minute ago. Let Zanick do it now.
No, no, gaslighting. Because the container would be, I mean, if you're using the molecules of the container, then maybe, but like just two random gas molecules crashing into each other, sure, it might change the trajectory of those said molecules, but that doesn't necessitate that there's pressure might change.
Okay. Can we stop there for a second? So yes, we all always know that this interaction, this collision, will result in a change of direction by definition. That change of direction would have to be, if these things have mass, be a rate of change of momentum, which is defined as a force. That only happens when there's a collision. It only happens when there's a change of direction. No other way that can possibly happen. It can happen off of each other, or it can happen off of a container. But the containment of the atmosphere, as I've said for many years now so far, does not require a physical membranic container. All it needs is weight. Weight, by virtue of weight, the airs and the gases, by virtue of their weight, contain.
Zanick,
Can you replicate it?
I know, but that just to make sure that everyone's clear on it, by virtue of their weight, that contains the molecules in an atmosphere.
In order to say this, though, you'd have to know where the atmosphere stops to know that.
I don't think that's a requirement at all.
You don't have to know where it stops to know
No.
to say that you have this thing that's containing it, but you don't know where it ends.
Because what did I say? See if you're paying attention, because you're talking kind of over me. What did I say contains the atmosphere?
The force of gravity, but regardless of what it is, though, regardless of what it is. In order to know that it's being contained, you need to know where that containment is happening at. Where is it happening?
I disagree. I don't think you need to know that at all.
You
All you
don't
need
even
to
know
know is
where
that
it's
we have
happening.
a
You're just saying there's this thing happening. I don't know where it's at, but trust me, guys, it's happening. I have no
That's
idea
not what
where
I'm
it is.
saying. That's not what I'm
Where
saying at
is
all.
it
I'm
then?
saying that
Where is it?
we have an atmosphere. How do you know? Well, we can measure this pressure gradient, and we can breathe here. We can't breathe there, and it goes up forever. But I know we have it. Where does it end? I don't know. Does that? If you don't know where it ends, then everything you said is invalid. That's not true. That's
Yeah,
patently
you're
false.
saying it. You're saying that it has this containment, but you don't know where the containment is.
But that's not part of the answer. Not a requirement of the answer.
But how can you say there's this thing you don't even know where it is, though?
That's like saying, can you answer this question? 4 plus 4, and you say it's 8. And I say, well, where are you
No, no, it's
located right
like
now? I'm in some forest. You don't know exactly where you're at. No, then that answer is incorrect.
No, that's
no, it's like
different.
saying
No,
it's
it's
like
not
saying
different. It makes no
unicorns.
sense. It's a non
It's like
sequitur.
saying unicorns exist, and then you say, "All right, where's the unicorn?" And I'm like, I don't know. It's out. They're out there somewhere.
That's not at all what I'm saying. I mean, don't. That's a
That's
little
more
philanthropic.
analogous because he's going with something you're saying is
No,
physical,
because I'm
but
saying,
you
have I
can't
shown
find like
evidence?
where it starts, where it ends, all that.
No. I would show you the unicorn. I'd bring you his horn. I'd cut his horn off and say, "Here, see, here's the horn." I cut it off his head. I don't know where is he now. I don't know. He took off after I cut it. He was pissed off at me.
You
But
gotta
here's his
stop killing
unicorn.
rhinoceroses.
How do you know it's not a rhinoceros horn? Well, I can do a genetic evaluation of this particular horn and say it came from a unicorn. See, I've given you evidence now. You're saying, "Oh, but we don't know where the unicorn is. We don't know where it is. You don't have
Wait,
it. You don't.
you
They
have
exist, but you don't have it. I had it, and I let it go,
You
and I
have
have the
DNA.
unicorn's
You
horn.
have DNA that's actually from unicorns. You're
I
gonna
have the horn
compare
from the
it against
unicorn.
what?
I cut it off. I told you, I'm paying attention.
Yeah, my question is, what are you gonna compare it to?
Saying
You have to
that I
have
have
base.
that I know the unicorns exist, and I don't know where they are. That's not
Yeah, but you
analogous
said
to.
you're
I
gonna
have gas
compare it.
pressure. I measure it. It's tangible. We measure the gradient with all the forces and elements. Books written, many books written on law of
You're
atmospheres.
trying
Atmosphere.
to.
You're
You're
not let me
jumping.
finish, are you?
You're
Because you don't want to
jumping.
listen to me.
I've
Do you
asked
think
you a
that someone
question.
has a unicorn horn somewhere in this world?
If you were saying there are unicorns exist, you would do that by to strengthen your case for you knowing that unicorns exist and espousing to think that they do.
You
Can
said
you
you're
wrap?
gonna take it in, DNA test it, and compare it.
Yeah,
How
there
are you
wouldn't be
gonna
anything that
compare it?
matches
What are
it.
you gonna compare it to?
More evidence. Horns off of a rhino. Horns off of a spotted lizard. Horned lizard. Horny frogs.
So you
You
don't
know,
have
you know what I'm saying.
another
Look,
unicorn to compare it
someone
to.
brought a silly analogy. Now you're just like double downing on a silly analogy. No, I didn't say
I am.
unicorn. I didn't say the equivalent of or the analogy of unicorns exist. I can't show where they are. They're up there somewhere. I said we have air pressure, gas pressure, follows all these laws that we've developed through of gas laws and law of atmospheres, and we don't know where
Yeah.
it ends. That does not say, oh, everything we said now is irrelevant and unsubstantiated, because it's not. It means quite the opposite.
I
We
mean,
don't
the
know where it
only
ends,
only
All right,
which
when
means
you
we don't
say
know
we
where it
don't
ends. It
know,
doesn't mean anything
Zanick,
else other than that.
When you say we don't know where it ends,
When I say we don't know where it ends, means we don't know exactly where it ends.
yeah, that's what I'm saying. Everywhere we've been so far, have we been inside Earth's atmosphere?
By how you define Earth's atmosphere will determine whether we have been there or not.
I don't know. How does NASA use it? We should probably go with NASA, right? Because they're the space people, the space experts.
Well, they talk about space starting at the Kármán line. They also talk about the Earth's corona. They also talk about all sorts of things in physics that talk about
Contradictory things.
these
There's
atoms or
contradictory
molecules that are
things they're
still
talking
trapped
about.
gravitationally to the Earth. I think any of these atoms, I think Jake said it or someone else said it, any of these molecules or atoms that are gravitationally attracted to the Earth, trackable, and see the results of them being attracted to the Earth, having weight, etc., that is our atmosphere. Anything that is not gravitationally attracted to the Earth is probably not our atmosphere.
Okay, there's a thing in logic and it's a fallacy and it's called kettle logic, which is a rhetorical device, which is what you're using, and it's wherein one uses multiple arguments to defend a point, but the arguments are inconsistent with each other.
So is the
Is this like the
question.
fallacy of the week?
Yeah, this is the one I wanted to bring to the table this week.
So is the question. So they're kind of in parallel. They're in unison.
the more ambiguous you make the question, and the more ambiguous the answer becomes.
Your
The more
evidence is that
specific the
you're
question,
bringing
the more
forward,
specific the
like,
answer.
you remember how you said one says it stops at the Cartman line, then another says it goes past the moon? That's what I'm talking about. That's a
Well, it's called
rhetorical
context.
device that you're like, yeah, exactly. You're saying we have to look at everything analytically. If we look at it in the big picture, none of this scales up and works.
As it shouldn't, because that's the definition of being specific versus being ambiguous. Don't you understand? See, you just painted yourself into a corner. You're not going to be able to get out now.
Oh, being analytical, you can. It's like you're saying that
That's
a
what I'm
guy
saying.
who knows all the parts of how a car, all the intricate parts of how the car works, doesn't actually know how the car works on the grand scale.
In every possible application, no. Like for example, I would be a good example of that. I build race cars. I fix cars. I do everything. I've been doing it my whole life, right? Do I know everything about cars? Is there any limits to my knowledge? Is there
Yeah,
any
but
limits to
that's
my?
you're
And I
on the
even
other
drive cars.
side.
Is there
You're
limits to
on
my
the other
abilities?
side.
Yes, there's limits on everything.
Yeah, you're on the other side. You're on the macro side. Like cars exist, dude. This you're saying I have all these particulars that add up to this thing that's containing everything, but then I don't know how to find the thing that I'm talking about, the big picture, the whole car. You know all the little ins and outs of the engine, all that cool stuff, but then all those little parts, when we put them together, make a whole contradictory story that doesn't work in reality.
Your analogy just fell apart on its face. But if you want to try to reconstitute it or fix it, I'm more than willing and patient to listen to you. But so far, we do know the atmosphere. We do see all the evidence that supports the atmospheric gradient. The law of atmospheres is a prime example of how we can do that.
Okay, where does it end?
I think the law of atmospheres talks about where it ends. In fact, maybe it does. In fact, I have a book here. We can probably I pull it right now. We can see what it says. But I guarantee what it is going to say is they're going to say space generally, as someone mentioned that word generally, stops at Carmen line. Why? I don't know. They thought it's a good spot where basically every change above 60 miles seems to be a very small change. So we're going to say, for all practical purposes, airplanes can't fly there, even no matter how
Okay, and
fast
then
they go.
we're gonna find another source that says the atmosphere extends as far as the exosphere.
Right. Because now
Okay,
we're talking about
that's my
atmosphere being.
point. Thank you.
No, you weren't listening. I
Now
even
we're
made
back to
that
the
point in my
kettle.
last one so it would stick with you and it just slid right off like you have a Teflon brain. I said that they generally think that that's a spot where no plane will fly no matter how fast it's going. There's so few particles at 60 miles high that it just planes won't fly. That's generally what the Kármán line means. There are still particles above it, still part of our atmosphere. Then there's this charged hydrogen atoms and things and the particles that are outside of the Earth, this exosphere type of thing. That's another dimension.
Are
That
they
has
within Earth's gravity?
other qualities. Are they attracted to the Earth gravitationally? I think some of them are. Maybe some of them aren't. I don't know. I don't know enough about it, but I don't think it makes all the other determinations or classifications wrong because, as I said, it's contextual. There's a context for what the space means in general terms. Specifically, you can say, well, is there any particles or anything charged or anything that we can see, luminous particles that get affected by the sun that are around the Earth and stay around the Earth? We'll say, oh yeah, there are. What do you call that? Well, they call that this exosphere, or whatever other names they have for it. I mean, this is not that hard to understand. It's not. We're not trying. I'm not trying to argue with you. I just think it's kind of funny that you have to really have a concrete answer where
So what's
everything
the
is
official stance,
contained as
Zanick?
knowledge and there's
Zanick.
no error and is hyper specific and we know exactly at 560,000 kilometers there's not one particle past
All
that.
This is
right,
all kettle logic. The whole
hold on,
thing.
Zanick. So the official stance is you don't know where the atmosphere ends. That'd be the official
Yeah,
stance.
as far as what is defined as the atmosphere, we have no idea where that really ends specifically, accurately.
Okay, that's a nice simple answer. Fine, you don't know where it ends.
Bouncing to each other. Okay, it's a constant measure progress, if you will. Yeah.
Yeah, I'm gonna, I'm not claiming to know anything. I'm the dumbest guy in the room, but I just the only way I can try to understand it is like You know how we look at time as like a measurement on a line. You know, we can say 1 minute ago we were talking about the petri dish, right? But like in order for our human brains to like understand time, we have to look at it like that. But like if you believe in God, or don't even if you don't believe in God, let's say you believe in Big Bang theory or whatever, you know, if everything we know ceases to exist, time doesn't stop. So that means like time never began. Like all time exists all the time. And somehow they're like manipulating that in order for a circuit to exist in both an on and off position at the same time. And I can't wrap my head around it, but that's the only way I can try to explain it to myself.
I have a big problem with this time thing. Time is a measurable concept, a man-made concept. Okay, it's not a physical thing. Okay,
What does that even mean?
time is not a particle or a wave. It's not. It's a concept, like a watch. Yeah, it runs linear from our understanding, but yeah, only the reference to this is a watch. Okay.
No, watch is a physical thing.
Yeah, but this represents a concept. Okay.
Concept
But
of
time
what?
Isn't it
itself,
just
it's not physical.
it's just like the quantification of the rate of change or something like that, you know. The breaking down of it into increments is arbitrary, but surely time as a concept or as a it's not a thing. I don't quite know how you describe it, but it's it's real. I mean things change. So
Progress of existence.
that concept is real.
The
It's
progress of
our
existence.
interpretation. But go ahead. John, go ahead.
Oh no, I'd kind of finished. Like it's the, I mean, I've heard the argument said, okay, if God created everything, then that means He created it before it existed. Like He had to exist before it existed, the thing which He created. So before is a temporal term. It exists within the framework of time. You can't exist before a thing without time existing. So, ergo, the argument is God cannot be outside of time because he had to exist either before or simultaneous to the creation.
Time is the progress of existence.
Yeah,
That's
it's
what's
a
so hard to.
logical contradiction, and it's a thought experiment. Yeah, what was first, the hen or the egg? Okay.
Yeah. What do you think, Zanick? What do you think time is?
Well, what it is the progress of existence. We move
Yeah,
through time.
it's okay. So the measurement of the rate of change, or the yeah.
Rate of
I think
change of.
I'm saying it. I'm saying it more clunky than you are.
I don't know if it's just a concept of rate of change. 'Cause I think the rate of change would be whether it's accelerating or slow. That's relative to something else. But just the progress of existence alone is time. We don't know how fast it, or if it's, you know, what that rate is. It doesn't have. It can be variable, but it does have to change.
Yeah.
It's kind
I
of
agree. It
like
doesn't have to be
velocity
60 minutes in an hour.
with
That's that we ascribe that value.
right. Also, kind of like an analogous to velocity versus acceleration versus speed. The speed is whatever that changes over time, and acceleration would be the rate at which that change over time occurs.
But
Well, yeah, that's right. Even through the entire accelerations, there is incremental speed existing at every one of those moments, isn't there?
Right, but the change of the change. It's the
Yeah.
second derivative of speed with respect to distance, where speed is just the first derivative of speed with respect to distance, and so time is kind of analogous to that. Just the
But
guess
like,
it would just be
regardless, sorry, regardless of like state of matter or change or speed, time never ceases to exist. You know, like time will always be there. So how is there like ever a beginning, or was there ever a beginning? Is time infinite in both directions?
Kind of has to be, doesn't it? I think. I mean, but then the argument arises: well, if time is infinite in the past, how can we ever arrive to here? Which then gets into, well, every moment exists individually. So yeah, I don't know. It's a bit of a head fuck if you ask me. But
That's the
if there's
classical
an
mind
infinite
fuck.
past, if there's an infinite past, you'd never arrive at this point. And yet here we are.
Yeah, I'm not even going to pretend like I understand.
Well, that's a profound statement. I never heard that one before, and that's actually pretty interesting.
Yeah, I liked it too.
I'm going to go back
I
to
don't have
smoking pot
I
again.
don't have a solution. Yeah, I don't have a solution for the problem, by the way.
I'm going to sit here and think about this for so long. I'm going to go back to smoking pot again just to try to stop thinking about it.
Or use TMT. Maybe you'll find the answer.
I need a laser and DMT. That's what I need.
I just did a search on that statement we both did. Wow, we're both kind of right. Time is, in fact, at first when it came up with the rate of change, then I said, is time a rate of change, or is just a change of existence? As I was kind of saying, and it says, we're both right, but it says time is more accurately described as the measure of the change of existence, rather than the rate of change. Though both are debated in physics and philosophy. So we both were.
Yeah, but I like this explanation because we measure time with a clock.
You can measure time with anything, or I mean, anything can be a clock. I guess that can measure the change of state with the passage of time, with the change of its change of existence can be seen. Anything that changes
Yeah,
existence can
yeah,
be
of
used.
course. Yeah, if we put this example to the movement of the sun and the moon, yeah, you can say it's a cycle. Yeah.
Well, it'd be relative to that, but what if you just had an hourglass? Because that would be related to the pull of gravity. What if you had something like, I guess the decay of the cesium atom? Then that's why they have atomic clocks. That becomes the best way. Then it's independent of other reference.
And the rate of change is variable as well, isn't it, Zanick? Because time slows down as you approach the speed of light. So the story goes.
The rate of change changes as well. So that's kind of like jerk in the physics, into the Newton analogy. You got speed, acceleration, and the change of acceleration is jerk. And then snap, crackle, and pop, if I remember correctly.
See, okay, here's a bit that I don't understand. So let's say, I wave my hand across in front of my face for 1 second, and then if I was traveling close to the speed of light in my field of relativity, that waving of the hand is the same amount of time, but it's different somewhere else. That could be 10 seconds somewhere else. So that the rate of change, because that all of that time is measuring the change of my hand passing in front of my face. So the rate of change. Geez, it's all right. I've just confused myself. I don't even know what I'm trying to say.
Yeah, it's hard for our.
It's variable. It's variable though. The change itself is constant. The speed to me that my hand moves is no different, but in respect to the theory of time, it is actually a different period of time it takes, depending on where you're situated relative to me waving my hand.
Supposed to be in a different gravitational field, it slows down or speeds up too, according to relativity. Yeah. Yeah, if you're real close to a black hole, your time will be dramatically different than here on
Yeah,
Earth.
wait, but you have to use a reference. This is always a clock, and we using this concept. Okay.
Yeah, but the clocks tick differently. So a clock close to a black hole, it may take a
Yeah,
month to
that's
tick it 1 second by.
hypothetically.
It may
That's
it may
hypothetical.
take well they've sort of measured this around different planets, but if you believe that, if you don't believe it, then I guess But they say they've measured it like in
Okay,
different like
okay.
around Jupiter and stuff like that. They've measured it real precisely and shown that it's true.
But here's the point: is it a measurement or is it a reading
Same thing.
with a device such clock? Yeah.
Same thing. You compare two clocks.
Yeah, but if you watch on your clock, yeah, you take a reading. You did not a measurement,
Yeah.
right?
Yeah, you set two clocks to be as accurate as you can possibly make them. You send one to a place like orbiting Jupiter that has a very strong gravitational field, and you keep one here, and you measure the difference in them. And one will tick slower than the other.
I would say you compare the difference, but you don't measure it. But that's yeah, I can do that.
That's is a measure. It is a measurement. That's what they say they do. I mean, I've never done it. I'm just telling
It's
you
a
what.
question how you define measurement. But hey, anyway.
Right. I'm not trying to get into a big argument that they've absolutely done it or not. I'm just saying that's what is
cool.
said. That's what they say that general relativity predicts.
So the story goes.
So the story goes. There's a good way to put it.
But then you got to
Karl,
think
just really,
the comparison
just
between
this
the
off topic.
two.
Sorry, my bad. Go.
If you're comparing the two clocks, right, the one that we have here we know as seconds and minutes and hours, with this one that's at Jupiter. Again, it's like a man-made measurement. Because if you didn't have the one on Earth with the time that we know to compare to, those seconds and minutes and hours that would be slower would seem the same. Like it's
Yeah.
just like a man-made system that we've created to wrap our heads around time.
If you ever watch that movie Interstellar, they used this concept in the movie, and they got it straight from general relativity. And they go to a planet that's orbiting a black hole, and you hear a tick in the background the whole time that they're on that planet. They're only there for like a couple hours, and you constantly hear a tick in the background in the music. It's like tick, tick, tick. Every tick that goes by was something supposed to have been like 7 hours or something like that, or a month or something. It equaled up. So then when they came back, 20 years had passed for the people on Earth for like their 2 hours that close to that black hole. And they used the actual math out of general relativity to determine just how much time's supposed to be different between that strong of a gravitational field and Earth.
Yeah, but to be fair, it's
It's a theory. It's a concept.
hypothetically. Yeah,
Yeah.
okay. Then I agree. The problem is when we reificate the concept of time to a physical thing, you know, uh, this is the definition of pseudoscience. I'm so sorry, yeah, but that's my position. Reificated concepts. Okay.
Yeah, look, I'd agree with that. I'd say that the thing which that concept describes, we all experience it. Our life goes by, and so you can't deny it. But yeah, I don't think you can reify it into something tangible or yeah. I don't even know the right word to use, but I think I'm on the same page as you.
Well, you know how like when you're a young child, let's say 5, 6, 7 years old, like a year seems like a really long time, and then the older you get, it seems like time goes by faster.
Hell yes.
Yes.
I think it's because, like, think about it this way: if you're 5 years old, 1 year is 20% of your life. At 50 years old, 10 years is 20% of your life. So, does 10 years to a 50-year-old feel the same as 1 year to a 5-year-old? If that question makes sense.
Yeah, it does. I
That's funny.
think so.
I'll give you an example. For me, when I hear 90s music, to me, the 90s weren't that long ago, but it was fucking 30 years. But genuinely, that song came out in 1998. That wasn't that long ago. And then I have to check myself and go, shit, that was a long time ago.
Yeah, I still look at cars from like 2000 as not old cars.
Not that old. Yeah. I'll tell you what to do, Cole. Next time you see a car like a 98 Camaro or something like that, think so that was 28 years ago from now. Think of when you first got your driver's license at 16, 17, then go back, whatever year that was, go back 28 years, and I bet you'll go, shit, that was an old car to me back then.
Yeah. It felt like, when I was young, get my driver's license, it felt like a 30-year-old car at that point. It was really old.
Yeah.
Another thing I question is like lifespan. Like a field, the average field mouse lives what, like 2 years? I don't know the real number. Let's call it 2 years. Does that 2 years feel like 75 years to the mouse?
Yeah.
And if that's the case, you know how like a mouse, the sound a mouse makes is like a little squeak. Well, if he's living on like a different time scale, to him, does that squeak sound like our voices do to each other now? Like, because it's slowed down?
I don't know. That's
Possible. Yeah.
This topic is
sounds like it's roaring like a lion to its own self.
You guys probably think I'm smoking pot right now, but I swear to God, I'm not.
No, but does the mouse sound like Barry White to another mouse,
Yeah, he's like, "Hey, what's up, mate?" But all we hear is,
Yeah. That's funny.
Shit.